Hello? ಇರಲಿ ಸರ್ ರೆಡಿ ಎರಡು ಹಾಕ್ಬಿಡಿ ಸರ್ ರೆಡಿ ಅಂದ್ರೆ ಕ್ಲಿಯರ್ ಕೇಳಿಸ್ತೈತಿ ಸರ್ ಯಾರಿಗೆ ಅವ್ರ ಇವ್ರ ತರ ಇದು ಸ್ಪೀಕರ್ ಇಲ್ಲಿ ಮಾತಾಡೋದು ಇದನ್ನ ಕೇಳಿಸ್ತದೆ
Please, learn delegates, invited speakers, faculty members, and student fraternity. A very good morning to one and all. To accomplish great things, we must not only act, but also dream. Not only plan, but also believe. With great joy and immense pleasure, I, Dr. Afra Kausar, Assistant Professor, Department of Chemistry, feel privileged to welcome you all on behalf of Organizing Committee of One-Day Online International Conference on Recent Trends in Advanced Materials, a befitting platform to stimulate, enhance, and refine skill sets of young researchers to take on global challenges. To begin with, a souvenir of the conference will be released by the dignitaries. Hence, I request our Honorable Principal, Deans, and HODs to do the honors. Dignitaries, kindly release the souvenir. I once again request Honorable Principal Sir and all the HODs to release the souvenir of the conference. Thank you, sir. A true welcome is never complete without accord a formal welcome to the August gathering.
Audio problem. Audio problem. Problem. Yeah.
Principal Sir, kindly present the welcome speech.
You just कैसा है? देखिए कैसा है just.
Hello. Hello. Am I audible?
Yes, sir, you're audible.
Yes,
A very warm good morning to one and all present over here on this online international conference. So it is my great privilege to welcome one and all the dignitaries present over here. At the outset, it gives me a great pleasure to welcome our senior member, Board of Management, Sri Shankaranaji I. Munwale sir, who is going to address us in a short while from now. So on behalf of our college staff and students, I extend a warm and sincere welcome to our senior member, Board of Management, Sri Shankaranaji I. Munwale sir. Welcome you, sir. At the outset, it gives me a great pleasure to welcome all the distinguished guest speakers who are going to speak and enlighten us, staff and students on this occasion. Professor Shipa Wang, School of Electronic and Information Engineering, China. So who has joined us. So on behalf of KLA Management, College and staff and students, I extend my heartiest welcome to Professor Shipa Wang. So welcome you, sir. Welcome you to our online conference. Then I welcome Professor M. Sardar Onses, Nanotechnology Application and Research Center, Material Science and Engineering, Turkey. So I welcome you, sir, on behalf of our college staff and students. And the third speaker, Dr. Gurumurthy Hegde, Professor and Director, Center for Advanced Research and Development, that is CARD, Christ University, Bengaluru. So I welcome you also, sir. And I extend my sincere welcome to all distinguished persons and contributors who are going to contribute their research article in this one-day international conference on recent trends in advanced materials. And I extend a warm welcome to all my colleagues and students who have joined this one-day international conference on recent trends in advanced materials. So dignitaries, PC Job and Science College has been established way back in the year 1957 by Karnataka Lingayata Education Society, KLA Society in Hubballi. Hubballi was known as the commercial hub at that time, but now Hubballi has become educational hub with 4 universities, many degree colleges, few colleges, schools, and colleges. So here, PC Jobbins Science College, a prestigious institute of KLE Society, has contributed and excelled in imparting quality science education to the needy students of North Karnataka region since its inception in the year 1957. It is the first college to go voluntarily NAC assessment and accreditation with the year 1999. So that was the first cycle. Consequently, our college has been accredited at A double plus grade with a 3.54 CGPA quite recently in the month of July 2023. Recognizing the quality of education rendered by college, the UGC has granted autonomous status in 2007 and extended it in the year 2012 and 18. So we are due for the fourth extension of autonomy. Based on the excellent performance in the academics, research, and concern for community, the UGC has recognized our college as college with the potential for excellence in the year 2007 and continued phase 2, and we have completed phase 3 also. The college has been recognized under Paramarsha scheme by UGC in order to train unaccredited colleges to go for NAC accreditation. So in this direction, 9 colleges have been trained by us. So out of 9 colleges, 1 college has been accredited already, and around 4 to 5 colleges they are about to submit their SSR for their accreditation. The research unit of our college is contributing remarkably in the areas of cancer biology, tissue culture, spectroscopy, material science, and kinetics. Faculty and students were able to publish and present their research output at national and international levels. The college is now taking strides towards networking with the different national and international bodies. The efforts have paid off, as many of our students have been recruited by multinational companies like Infosys, Wipro, Nestle, and that shows that our placement cell of our college is also very active. So such a multifaceted institution, that is science institution, so is organizing today on behalf of School of Physical Sciences, comprising physics, chemistry, and electronics, organizing this one-day online international conference on recent trends in advanced materials. So with these few words, once again, I extend my heartiest welcome to one and all joined this international conference. Thank you. Thanks a lot.
Thank you, sir, for a warm welcome. On this momentous occasion, it is our proud privilege and fortune to have with us Sri Shankarna I. Munvalli, sir, Honorable Member, Board of Management, KLE Society, Belgavi. I request him to bless us with few words.
I, Shankarna I. Munvalli, Member Board of Management, KLE Society, Belgavi. The KLE Society is one of the largest educational organizations in South Asia, which was established in 1916. It has been transformed into a veritable movement in providing quality education over the past 107 years. The society being led by our Honorable Chairman, Dr. Prabhakar Kore, the KLE family now encompasses catering to the needs of more than 1,39,000 students. The society has one of the rarest distinctions of being conferred with 2 deemed universities, that is one in medical education and another one is in technical education. In in 2016, the society celebrated its centenary. Our Honorable Prime Minister Sri Narendra Modi ji graced on that occasion. Further, the KV Society's PC7 Science College was established in the year 1957 for imparting basic science education and nurturing the wonders of science. The college has been accredited for 5th cycle and awarded A++ grade with a CGPA of 3.54 by NAC. Recognizing the quality science education rendered by our college, the UGC has awarded autonomous status to our college since 2007. Regarding today's conference, material science is an interdisciplinary field of research that involves the physics, electronics, and chemistry of materials, including theoretical and computational study. Chemists and physicists play an important role in discovering new material based on simple intuition arising from the knowledge of the structure and bonding. By adopting ingenious systematic strategies, and electronics gives the shape to the technology. To ensure that this conference will provide a platform to academicians, teachers, and young researchers to interact with distinguished scientists in the field and to know the latest advancements in the field of material science through online platform. It also aims at kindling interest in the minds of young students to pursue research as higher career. It is anticipated to widen the scope of interdisciplinary research among teachers and research scholars. Hope you will make a proper use of this. Hope you will make a proper use of this conference.
Thank you, sir. Indeed, you have always been our support system in all our endeavors. Well, Albert Einstein said, if we knew what it was we were doing, it would not be called research, would it? It is on this occasion like this, we get opportunities to test our knowledge and understanding. We look forward to getting exposure about what the best of brains can do about this very dynamic issue, that is recent trends in advanced materials. Not delaying, let us begin with the keynote session. We have with us Professor Shifa Wang from the Chongqing Three Gorges University, China. I would request Dr. S.B. Kausalgi, sir, Associate Professor, Department of Chemistry, to introduce our esteemed keynote speaker.
Very good morning to one and all. Today, it's my immense pleasure to introduce an outstanding personality, Professor Shifa Wang, who is keynote speaker of today's international conference on recent trends in advanced materials. Shifa Wang is an associate professor in the School of Electronic and Information Engineering in Chongqing Three Gorges University, China. and is a guest editor in the following international journals: Frontiers in Materials with Impact Factor 3.2, Frontiers in Chemistry with Impact Factor 5.5, and Journal of Physics Condensed Matter with Impact Factor 2.7. And sir is also the editorial board member of 7 journals. He obtained his PhD degree from University of Electronic Science and Technology of China. And thereafter, he worked as an engineer in China Academy of Science, Space Technology, Institute of Physics. His recent work is focused on the preparation and characterization of optoelectronic information and intelligent materials, as well as application of intelligent algorithm in material synthesis and performance prediction. Sir has published over 150 science journals, and to his credit, he has written 2 books and 1 book chapter. With this brief introduction, I conclude my introductory speech. Thank you.
Thank you, sir. I now request Professor Shifan Wang to take over this mic.
Hello, everyone. My name is Wang Sifa. I come from Zhongguo, Wanzhou. I turned the camera off due to network concurrency.这个，它不准共享屏幕，你看。这个，那怎么弄？不准共享屏幕。我问一下啊。Sorry. Can I show screen?
Not shown the screen.
So we are not able to see your screen. Yes, sir, you can share the screen.
ಅಬ್ಬಾ ನೀನ್ ಇಂತ ಕೆಲಸ ಮಾಡ್ತೀನಿ ಬೆಂಗಳೂರ ನಾನು ಗೊತ್ತಾ ಸೋಗೇಶ್ ಎಲ್ಲ ಇದ್ ಮಾಡಿಸ್ತಾ ಇದೆಲ್ಲ ಎಷ್ಟು ಮಾಡ್ತೀನಿ ಜೊತಾ ಸೋಗೇಶ್ ಎಲ್ಲ ತೊಳಿತೀನಿ ಗಿಡಗೆಲ್ಲ ಒರೆಸ್ತೇನೆ ಮುಸ್ರೆಲ್ಲ ತೊಳಿತೀನಿ ಇದೆಲ್ಲ ಜೋಡಿಸ್ತೀನಿ
ಇವತ್ತು ಹೋಗಿ ಹೇಳಿರ್ಬೇಕಲ್ಲ ಎಲ್ಲದು ನಿನ್ನೆ ರಾತ್ರಿ ಮಾತಾಡಿದ್ವಿ
ಎಲ್ಲಿ ಮಾತಾಡಿದ್ರೆ ಗೊತ್ತಾ
I request the participants to kindly mute yourself.
ನಂದು ನಿಂದು ಅನ್ನೋ ಪರ್ಸನಲ್ ಅನ್ನೋದೇ ಇಲ್ಲ ಮದುವೆ
ಇಲ್ಲ ಶ್ವೇತಾ.
ನಮ್ರತಾ.
ಎಲ್ಲಾ ಗಂಡಂದ್ರು ಅವ್ರ ಹೆಂಡತಿಗೆ ಎಷ್ಟು ಇದು ಕೊಡ್ತಾರೆ.
So your screen is visible to us. You can begin.
ಜಗದೀಶ್ ಸರ್, ನಾವು 2 ನಿಮಿಷದ ಕೆಲಸ ಸಲುವಾಗಿ ನಾವು
申请把屏幕关掉，已经关了哈。现在可以看到啊？可以看到啊，然后就可以了。Dear Professor Cunningham and everyone, my name is Wang Sifa. I come from Chongqing, Wanzhou. Thanks for the kind invitation of the Inauguration committee. I have the honor to show with my work in recent years. The title of the report I show with you is Spatial Illuminance, Photoluminescence, Photocatalysis, and Performance Prediction. This is my contract information. Welcome to communicate with me. The main contents of my report include the following 5 aspects. 1. Illuminate. The part mainly introduces some basic concepts and application of illuminate. 2. Photoluminescence. This part mainly introduces our recent work on photoluminescence of illuminate. 3. Photocatalysis. This part mainly introduces our recent work on photocatalysis of illuminate. 4. Performance prediction. This part mainly introduces our recent work on predicting the performance of illuminate. 5. Prospect. This part mainly introduces the work related to illuminate that can be carried out in the future. First, let's look at the content of the first part, illuminance. Illuminance is usually considered to be a source containing illuminate air. Our common illuminate mainly include aluminum oxygen 3, well iron, yttrium, and Nassland series. Aluminum 12 oxygen atom, while A represent cluster strontium barium. A3 aluminum 5 oxygen 12, while A represent yttrium Nassland series shipped service. Aluminum to oxygen 4 can also be returned this. This is the focus of our research. The I help. We can filter space by looking at the periodic table. In the periodic table,
ಆಯ್ತಾ ಇಡುವರ ಲೇಟ್ ಒಂದ ಕೆಲಸ ಅಲ್ಲ ಹೇಳಿದೆ ನಿಮಗೆ.
my user books with I read them. With I read them to filter from it. This element includes uranium, magnesium, calcium, potassium, magnesium, iron, cobalt, nickel, copper, zinc, and cadmium. From the structure point of view, owning barium aluminum, calcium aluminum, strontium aluminum, and barium aluminum cannot form a cubical phase. Nickel aluminum is the most unique one and can form a partial inverse spatial structure. In other words, part of aluminum equivalent occupies the temperature space, and the other part occupies the occupied space. All aluminum containing cubical phase. It is easy to form cubical phase during synthesis. Aluminum show other application prospects in the field of humidity sensing, GPS pitch antennas, absorption, lightweight helmet, space station, lightweight window, pigments, luminescent substrate materials, and photocatalyst due to its high
Southwestern China University professor, associate professor.
Not specific surface area, net mass, transparency, and high charging, current transfer and separation efficiency. Therefore, aluminum has gradually become the focus of research, limited by experimental conditions. Our laboratory mainly focus on the photoluminescence and photocatalytic architecture of aluminum. Second, photoluminescence. Talking about photoluminescence, let's first look at the principle of photoluminescence. First of all, luminescence exists in the four laws. One, there is an expansion process, that is the process in which the architecture of fluorescent substrate itself can absorb external radiation energy. So, architecture else must introduce matrix luminescence. Three, there is energy transfer between architecture else. Four, in the process of luminescence, the non-radioactive transition causes the luminous efficiency of the forceful to be lost. Photoluminescent materials can generally be divided into four categories. One is the materials can generally one is the material used for fluorescent lamps. The second category is long afterluminescent materials. These materials can be explained by three models: Hall transport model, two return trip model, and three configuration for delete model. The third class is up-conversion luminance materials. Up-conversion photoluminescent materials that absorb multiple photons of low energy and long wavelengths and emit photons of high energy and short wavelengths. The difference with common down conversion luminescent materials is that it absorbs long wavelength light and emits short wavelength light. The fourth class is the luminescent materials. Proposomer display plates. Illuminator has high anti-irradiation ability and is widely used in space station window lighting system. To dimensional code, road sign, and so on. This is an illuminator-based space station window lighting system developed by the China Academy of Space Technology. Further illuminator will be used as a luminescent. It still has the following disadvantages. One, the introduction of production of mature illuminator luminous materials, in addition to yellow, green, and blue. Other color of luminous materials are still under research. Two, xenon lamp excitation difficulty. Three, low brightness. Four, illuminator luminescent materials are easily hydrolyzed in water or in humid air, greatly affecting the luminescent properties of the luminescent materials and even lose light storage. In order to overcome the above shortcoming, illuminator and illuminator-based forceful will synthesized a single component of magnesium illuminator, beryllium illuminator, copper illuminator, and nickel illuminator will synthesized by polyacrylamide gel method. The Fourier phasor illuminator was confirmed by XRD and the FTR catheterization. By TM catheterization, we found that this illuminator will uniformly disperse the nanoparticles. The color properties of the synthesized illuminator will estimated by the UV visible diffusion reflectance picture and the conclusion formulas of color parameters. In addition to COVID illuminator is blue, other illuminator are white. After testing this illuminator with a fluorescence spectrum for 2 millimeter, we found that there was no corresponding fluorescence spectrum. Then the corresponding fluorescence spectra are obtained by excitation of a laser a strong laser source. Also, the luminescence photometer of this illuminator have been observed. The application of illuminator in the field of luminescence have been greatly limited by need for strong laser excitation. Cerium and magnesium co-doped ammo illuminator. First of all, will prepared by co-doping of cerium and magnesium else to serve the shortcoming of illuminator cannot self-luminescence. The introduction of cerium and magnesium ions has a great influence on the local structure of the system. The agglomeration of particles become very obvious. However, after the introduction of cerium and magnesium ions into illuminator, the lamp source can stimulate this phosphor to emit different color of light. In particular, the phosphor emitter red light was obtained. In addition, we use the surface plasma resonance effect of metal particles to synthesize a variety of metal particle cupped illuminate phosphor. When magnesium particles were introduced into magnesium illuminate precursor, the surface morphology of the system change into instant notice. The phosphor showed a red luminescence band at 613 to 619 nanometer. Meanwhile, magnesium illuminate phosphor coupled with titanium, magnesium, cobalt, and nickel metal particles were prepared by a tricyclic assistant acrylamide general method. Similarly, their self-morphology is similar to that of magnesium coupled magnesium illuminate phosphor from a laminar structure. Titanium, magnesium couplet and nickel metal particles introduced into the magnesium aluminum system can produce a variety of colors from white, grayish black, blue to cookies blue. Copied metal particles are painted into the magnesium pyramid system can cause fluorescence quenching of emission. Peak at 395 nanometer and enhance of emission peak at 405 nanometer, while the titanium and magnesium metal particles infused into the system can bring the enhance of visible emission peak at 425 nanometer. In addition to the use of metal particle coupled aluminum, where synthesized aluminum coupled aluminum phosphor. However, the luminescence of this phosphor is contrasted in the blue region. And generally tenders is that the luminescent intensity of waning peak of COIO and NIOIO decrease with the increasing of century temperature. Now, let's make a brief summary. When a single couplant aluminum phosphor has been synthesized and has photoluminescent property until the extinction of string laser light source to the MIOCM phosphors well synthesized and exhibited high photoluminescent properties. Three, the MIOM phosphor well synthesized and exhibited high plasma resonance effect. Three. Now let's move on to the third part of photocatalysis. Guangzhou is located in the heartland of the Three Georgia Reservoir area. There are many pollution sources around, which have caused great pollution to the water environment. It's used in printing and dyeing plants, textile factory, medicine and food process plants, and antibiotics used in agriculture. This have attractive in the attention of local authorities for water pollution in the Yangtze River. Therefore, many degradation methods have been developed to degrade this or antibiotics in water, such as electrical catalysis, thermocatalytic, electric catalytic, photocatalysis, biodegradation, and adsorption, and so on. Among these technologies, photocatalysis technology is a green technology that uses light energy to drive the degradation of this or antibiotics. The key of photocatalysis technology is the choice of photocatalyst. Aluminum is an important photocatalyst, but it has the following disadvantage. One, large band gap value. Two, not easy to recycle. Three, unresponsive visible light. Four, utilization of light energy. To address this shortcoming, we propose some solution. One, the difficult constructed under extreme sensitized condition to respond to visible light. Four, and two, the band gap of aluminum is reduced by iron dropping. Three, the photocatalytic activity of aluminum was enhanced by constructing multi-heterojunction composite photocatalyst based on band arrangement theory. For the photocatalytic activity of aluminum was enhanced by surface modification of lower metal particles. This most is mainly to solve the problem of easy handedness of aluminum. The extreme condition we adopted where the synthesized experiment of aluminum carried out with the help of the copied source. The copied source radiation functionality of the China Academy of Engineering Physics, which places take advantage of the feature of the polyacrylamide general method. That acrylamide and methionine this acrylamide could be irradiated and polymerized. You put a white water in the equipment. You take it out and it transparent. The aluminum particles synthesized by this improved methods are small and more uniform and difficult constructed on its surface. Due to influence of the surface defect structure in impurity energy level, band gap values above 3.9 returning watts also have visible photocatalytic activity. We also synthesized the magnesium aluminum nanoparticles by changing different kinds of metal salts, which have a great influence on the physical purity, morphology, and physical chemical property of magnesium aluminum. The second solution is iron dropping. CMAO photocatalyst was synthesized by means of ion dropping. The photocartoonist successfully reduced the band gap value of magnesium aluminate, and at the same time, the blown couplant become more obvious, while the copulate content was reduced. It was found that the CML photocartoonist showed high photocartoonic activity in the degradation of methylene blue by simulating solar light. The third solution is to construct a Hertz junction. Three binary Hertz junction are constructed MaOCO, MaOYMO, and carbon MaO. Both as solvent and photocartoonist, binary Hertz junction show stronger copper binarity than magnesium aluminate as a single covalent. Simultaneously, we are also similar or carbon nitrate as a nutrient transport carrier to construct a ternary Hertz junction photocartoonist, such as MiOCO, MiO, MiOCN, carbon nitrate, YMO, and MiOCO, YMO, coupled with the binary Hertz junction photocartoonist. The photocartoonetic activity of ternary Hertz junction photocartoonist is further improved. The fourth solution is the sulfide modification of double metal particles. We modified many note metal on the surface of magnesium aluminate, but found that it accelerates the handliness of aluminate occupations several particles. Therefore, CNIU MIO photocartoonist will synthesize in different carbon order by photojunction method, and their photocartoonetical activity will study. This work is being submitted. Due to time convergence, sections 3.3 and 3.4 will not be covered. Let's summarize this section briefly. One, a single covalent aluminate photocartoonist was synthesized by convergent irradiation assistant polyacrylamide general most. Two, multi-Hertz junction photocartoonist was constructed by Martin. Step polyacrylamide general method combined with the low temperature center technique. So the effect of various parameters on the photocatalytic activity of the photocatalyst was discussed for free radical validation experiment discussed in detail. Let's talk about the fourth part, performance prediction. Why do we make a performance prediction? What is the purpose? One, cost reduction. Two, same time. Three, optimize experiment results. Four, develop new materials or discover new phenomena. For the performance prediction of photocatalyst, the current application mainly include one, novel photocatalyst is discovered based on the combination of the first perception and intelligent algorithm. To the optimal photocatalytic experiment condition will predict based on the experiment parameter and degradation percentage date. Three, prediction of photocatalytic activity of photocatalyst based on observance dates. We mainly focus on the latter two parts of study. To predict the degradation percentage, it is necessary to perform a large number of photocatalytic experiments, obtain different experiment parameters, and they select a suitable neural network model for train and then predict. This is a new network model which include input and output parameters as well as hidden laser. They predict results are basically consistent with the experiment results. Similarly, we prepared the BIOCM composed photocatalyst and obtained the relevant experiment results. These are experiment results. We established the BP neural network through MATLAB software and set the cycle time area and other related parameters, and they made the prediction. Experiment results were consistent with the predicted results. In this way, to predict the percentage of degradation requires more experiment data to obtain a good prediction effect, which is time consuming. At present, there are about 27 popular neural network models, which we shown in the left figure. When we perform photocatalytic experiment with many major absorbance current of solution at different time interval, which are composed of many data points. If we calculate the percentage of degradation, we only get one set of dates. However, if the absorbance cover is calculated, many sets of data can be obtained, and the conclusion accuracy can be improved. When forecast, we can choose the right model to train. We're usually choose BP, the neural network model for train, but this model is easy to fall into local extreme values, and the result of each prediction are inconsistent. Therefore, we usually combine some popularization algorithm, such as genetic algorithm, where algorithm are our algorithm or particle sum algorithm to train and predict. We trained the absorbance cover of MIO, CNYMO, photocatalyst by using the above different algorithm, and finally found that the BP neural network model optimized by genetic algorithm was highly consistent with the experimental results. Therefore, the prediction of photocatalytic activity of MLCN-YMO photocatalyst by using this model can be extended to other similar photocatalysts. Let's just briefly summarize this part again. One, BP neural network algorithm models have been used to predict the degradation percentage of photocatalyst. Two, BP neural network model optimized by several intelligent algorithms have been used to predict the absorbance data of dyes degraded by photocatalyst. Three, BP neural network model optimized by genetic algorithm is considered to be the best model to predict the absorbance data of photocatalytic degradation of this. Finally, the fifth part, prospect. Let me briefly describe some of the work will be doing. One, the M-aluminate based heterojunction magnetic separation photocatalyst will constructed by aluminate and magnetic materials. Two, coupling of parameter with metal organic framework structure, high entropy alloy, and so on. So new intelligent algorithm models need to be developed and applied to predict the photoluminescence or photokinetic architecture of parameter-based composed. Finally, I would like to thank PC Driving Science College again for the kind invitation. If there is something wrong, I hope there will be a lot of criticism and clarification. Thank you for attention.
Thank you, sir, for your wonderful talk. I hope the audience has benefited from it. Sir, there are a few questions for you from the audience. Shall I read out, sir? Professor Shipasa? Sir, am I audible? So there are a few questions from the audience for you. Sir, I read out the first question. They want to ask, what size of magnesium do show SPR property when doped for any materials? What size of magnesium do show SPR property when doped for any materials? So the question is, what size of magnesium do show SPR property when doped for any materials?
I will strike her again for the.
So the question is clear. So should I repeat it once again? The participants have asked a question to you, sir. They are asking, what size of magnesium do show SPR property when doped for any materials?
咋回事？我这有了，咋回事呢？那个，他要看我上面两眼，网友是在打那个障眼字，这儿看不到了。对话框啊，这个呀，从来从这儿看，这儿哈，在哪里？There's what sense of my way.
So we have posted the question in the chat box, sir.
那先看网友那个嘛哈，这是回的是呢。 Thank you for your very new question. The gamma ray radiation experiments has to be doing at the China Academy of Engineer Physics, which is not open to the public. It take a long time to do experiment here, and they can only do experiment when their reactor is empty. We're also looking at other places to do this experiment. As for your second question, it is perfect. Okay. Many research group are using neural network model to predict the prosperity of other new materials, especially in the development of new materials. We are also using certain neural network model to predict the particle purpose of aluminum.
Yes, sir. Thank you, sir. For any of the queries, you can contact us later and we can solve the questions. Thank you, sir, for your informative talk and fruitful discussion. Moving forward, we are delightful to have with us Professor M. Sardar Onsus, Nanotechnology Application and Research Center, Material Science and Engineering, STS University, Turkey. I now take the privilege to call upon Dr. Khan to introduce the guest of honor.
Thank you, Afra. It gives me immense pleasure to introduce young and dynamic researcher and scientist, Professor Mustafa Sardar Onsus, Nanotechnology Application and Research Center, Material Science and Engineering, RISS University, Talas, Turkey. He is currently a director and founding head, Nanoscience and Nanotechnology Interdisciplinary Graduate Program. His research career speaks his testimony of his excellence in research at the age of 40 years. He did his BSc and MSc from Istanbul Technological University, Istanbul, Turkey, and is graduated within top 1% from the Istanbul Technological University. He got his PhD in chemical engineering from University of Wisconsin-Madison, USA. Then he moved to postdoctoral research at Department of Material Science and Engineering under the supervisor John Roger at University of Illinois at Urbana-Champaign. He has about 91 research publications in various international research journals of high repute, and he has totally 11 patents in his name, and his research achievements results in 1061 citations with H index of 18. He has totally 24 research projects from various funding agencies across the globe, and totally 8 PhD students, 7 MS students, and 1 postdoctoral students are pursuing and completed their degree under his guideship. And the Professor Sardar Onsus has many awards and recognition in his name and from the young age. So he got various scholarship for graduate and PhD, and he got High Performance Research Award from RISS University, Outstanding Young Scientist Award from Tuba Jebib, and Outstanding Scientist Award from as an engineering faculty, RSS University, gold medal for patent application at Istanbul International Invention Fair, and 2020 has been awarded with Young Scientist Award from Science Academy of Science. And then he also awarded with Research Incentive Award from Mustafa Parler Foundation. And he has many more awards in his pocket, but there are many awards. So with this brief introduction, I welcome Professor M. Sardar Anses for the technical session. Thank you, sir.
Okay, thank you very much. First of all, for the very nice introduction. I'm not able to share my screen, actually. I think I need the permission for sharing the screen.
Yes, sir, you can share now.
No, it's okay. Okay. So now can you see my screen? I should share the this one.
Yes, sir.
Okay. First of all, thank you very much for the very nice, for the very kind invitation and for the very nice introduction. It's a great pleasure for me to give this talk in this conference, and I see that there is very large audience. So I hope it will be a good interaction with the audience and a good seminar. So today I will talk our recent research activities, mostly on encoded surfaces using what I call as like stochastic processing of nanoscale materials. But I wanted to start my talk briefly talking about my research group and the other directions, just in case there are opportunities for interaction later. I'd like to thank my students and postdocs and funding agencies at the very beginning so that I'd not forget the credit. So this work would not be possible with the support of the funding agencies, as well as the hard work of the students and other researchers. And we have many international collaborators, some of which I will cite during my talk, but in the past and also in the currently, we are collaborating with different researchers across the world. And I hope we will have some collaborators with India. Maybe after this conference will help in that, initiating such collaborations. We are located in Erciyes University. It's in the middle of Turkey. Kayseri is a lovely city, and we have a nanotechnology research center here, which some infrastructure that we use in the experimental facilities. We also have some other research centers in our university and other universities that we do our research using those facilities. And overall, my research group, we are mostly interested in surfaces, and mostly it's like nanostructured surfaces, and we often use processes of self-assembly. And we typically, what we do is, if we are an engineering group, so what we do is we take different building blocks, and those building blocks sometimes we synthesize, but often we also collaborate with other groups who has expertise on synthesis of such materials like colloidal nanoparticles, sometimes polymers, biomolecules, for example. And then we do use some processes, either wet processes, sometimes dry processes like physical vapor deposition. Electrohydrodynamic process is an important part of our research, as I will talk I will mention in my talk, like e-jet printing or electrospinning. We often use such techniques. Sometimes we use lithography techniques if we want to fabricate ordered arrays. And we typically do these for different applications, like encoding. I will talk today An important part of our research is about liquid repellent coatings, super hydrophobic coatings, for instance. And through collaborations, we also do some other work, let's say in sensing using surface enhanced Raman scattering. We have some collaborators who work in biomedical engineering, so we study the antibacterial properties of our coatings in some cases, and some other collaborations which we are part of it is like fabrication of supercapacitors or optoelectronic devices. We provide some materials or surfaces for those works. Just to give some idea of these other directions, one work we are working, this is one direction, is multifunctional super hydrophobic coatings. This is, of course, we have a lot of publications, but also this is a work that is motivated by the application. So we also have several patent applications, and as you see video that shows these applications of such coatings, we typically try to improve the mechanical robustness of these coatings, and also try fabricating such coatings using different set of materials, let's say like more eco-friendly materials and similar cases. And for example, just to give an example, for example, a recent direction in this area, and this was again in collaboration with Professor Hans-Jürgen Butt of Max Planck Institute. We are working on sustainable fabrication of super hydrophobic surfaces using mechanochemical processes. This is a direction which we think that there's a good potential. Actually, we have a couple of other publications just published in this direction. We use solvent-free processes to graft low surface energy molecules. And so we can fabricate super hydrophobic surfaces, materials without using other solvents, any solvents. And these are some examples where we investigate mechanical robustness, transparency, and we also try to add additional functionalities to these coatings, not just liquid repellents, but also bacteria killing, as well as source activity, so that you can use the same surface for sensing of molecules. So this is just, I wanted to mention briefly about this direction. Another direction, especially motivated in the COVID period, was developing surfaces that are antibacterial, but at the same time they have the ability to detect and sense bacteria. This work, for example, from our research group, we developed materials which was composed of silver and copper oxide using a green fabrication process. These surfaces were very effective in terms of bactericidal properties. So they were they can rapidly disintegrate bacteria, but at the same time we could use the same surface to detect bacteria, and especially by using machine learning techniques, we could identify the type, the strain, the bacterial strain that is on the surface, and we showed up to like 5 bacteria we could identify with such surfaces. And again, related work in collaboration with some other professors in our university, we developed multifunctional mats which has antibacterial as well as antiviral properties, but at the same time they have photocatalytic activity, so you can use the same surface to kind of clean the surface if it is contaminated. Just these were just as a flavor of other directions that we are pursuing. In case there's some interest, I wanted to share. But the main topic that I will talk today is fabricating encoded surfaces. The encoded surfaces, why do we need to fabricate such surfaces? Well, one major motivation is counterfeiting. Even though there are other directions, there are other reasons to study encoded surfaces, but counterfeiting is a significant issue in the world, and especially a significant issue in some developing countries as well. And as you see the numbers here, the trade in counterfeit and pirated goods now stands at like 3.3% of the global trade. And this is not just an economical problem, but also it has social and health consequences. For example, in the case of fake drugs, it also affects the health of the individual. And I will give you more examples later. Even it can result in the death of individuals, because if you use a fake drug which is not effective in treating a disease, for example. And also this is indicated in the Sustainable Development Goals of the United Nations, indicates illicit trade has a very clear negative impact on the society. And you can see here almost all industries, this is a problem, that there are fake products, counterfeit products in almost all industries. But other than the counterfeiting, of course, authentication of documents, of course, a well-known example you can think about the banknote, but the passports, IDs, or important documents may need authentication. Also, with the rise of Internet of Things, there are many objects around, and each object should have an ID, and you should be able to ensure the authenticity of those objects. So that's another important part where there is a motivation for developing encoding mechanisms for this kind of applications. And other applications, some biotechnology needs barcodes, for example, and even forensic science, the taggants, for example. You can use the taggants as a kind of a physical evidence to associate the individual with the offense, or other cases where you need such surfaces. And here, particular materials, as we are in a materials conference, but particularly nanomaterials, I believe has a strong potential here, because the nanomaterials have size-dependent properties, and they have unique properties, so that they make them as excellent encoding elements. This is a review paper earlier published, as you see an example, and you can see each material, each nanomaterial, depending on the size, geometry, the structure, composition, has unique properties. And also a good thing is they have different properties, not just optical, for example, but electronical, magnetical properties, so that you can design different types of encoding systems by using nanoscale materials. And this is, I believe, why it attracted a lot of attention in the fabrication of encoded surfaces. Just to make some definitions here, I believe is useful, because maybe it might not be familiar for some of the audience. Generally, we classify two types of approaches in encoding. One is deterministic, what I refer as, and this is what we are actually very familiar from daily life. The one-dimensional like barcodes or two-dimensional QR codes we already use in our life, and these are deterministic. What we refer as deterministic, which means that they are produced with a reproducible process. And this is also still an important research area, and people are still developing advanced, barcodes which have, are fabricated with unique nanoscale or other materials, and they have some unique like light absorbance, emission, etc. And I will show you some examples here. And this is what I refer as deterministic barcoding, deterministic encoding. But another direction that is, I believe, attracting more and more attention is the stochastic one. This is based on random structures. I think the best example is, the fingerprints of the human. All of us has fingerprints, which are composed of randomly oriented lines, and each of us has an unique fingerprints. So and it's random structure. It's very difficult, to kind of replicate it. And these kind of processes are attracting a lot of attention. And these are typically fabricated with a stochastic process. The process itself produces random structures so that even maybe the manufacturer itself cannot repeat the same structure, but this is good for this application. So it gives you more kind of security. And what we try in this research direction, our research program focuses on designing and fabricating novel encoded surfaces using different materials and mechanisms for applications. And I will talk you some examples of both deterministic, stochastic, and hybrid, where we use both of them using different materials. So far, we use different materials, as you see, polymers, quantum dots, metal nanoparticles. We use graphene, and even some natural materials or biomaterials. And we use like different mechanisms, like I will talk solid state dewetting, electrohydrodynamic instability, and some crystallization growth processes seem to be interesting for fabricating such surfaces. And there are many different characteristics that can be useful for these applications. For some cases, we are looking for randomness, so that it's very difficult to, and even maybe in principle impossible, to repeat the kind of the output of the system. Robustness is very important. Mechanical robustness, thermal robustness, depending on the application. Encoding capacity, again, is an important parameter because depending on the application, you may need to generate many different codes. For example, let's say you have a production line, and you produce like say millions of products, so that your system should be able to fabricate millions of barcodes, for example. And addressability is important for practical authentication. I will show some examples. Of course, cost is important for some applications. Biocompatibility and even edibility is important, because there's a lot of recent research on drug safety, so that some labels that can be directly applied on drugs, so that it should be edible, composed of edible materials. And of course, other considerations include flexibility, fabrication compatibility, authentication, of course, is important. In some cases, you want very practical authentication using a smartphone, but in some cases, of course, maybe more complex surfaces can be authenticated using techniques like Raman spectroscopy. And an important part of this research is of course, image analysis and developing algorithms for feature matching. And this is also collaborative work, like some folks who have experience in computer science typically involved in this research, because it requires a lot of these algorithms for pattern matching. Just some examples from our research group. An earlier example, we used a microfluidic assisted assembly to pattern polymers in the first step. And then we designed a second set of microfluidic molds and patterned some molecules which are active in Raman spectroscopy, and so that the resulting patterns could be authenticated in Raman microscopy. And then we could design barcodes, as you see it here, using different materials, different combinations of materials. If you use more materials, then that's a good way to increase the encoding capacity of these barcodes. This was one example. Another example of deterministic barcodes was kind of using the tattoo approach. What we did was we used inkjet printing to print silver inks. This is a useful ink composition as a reactive silver ink, which forms silver nanostructures upon printing and a brief annealing step. But we also added some molecules, let's say rhodamin 6G, methylene blue, but in principle, you can add any molecule you want. And then we fabricated some patterns. It could be either some complex image like a butterfly, or it could be like just a barcodes as you see it here. The one innovation here was we could print these on a tattoo paper and then actually transfer on different objects. And this is one example we show on a copy of the painting. This is a famous painting. And as you know, such paintings, it's very important to have the authenticity so that we demonstrated the concept here by attaching a barcode so that you can see it here. It's like a small one. As you zoom in, it becomes available. Of course, with just your naked eye, you can see the barcodes, but you need to check the Raman microscopy to actually ensure that it's the right barcode, because only if you select the right, Raman shifts, then you can see these red and blue colors in the Raman mapping image so that you make sure that this is the authentic barcode. So these are some examples of deterministic barcodes, but I will more talk on the stochastic part in today's talk. And this brings us to a concept which we call as physically unclonable function, in short, PUF. This is an interesting concept, originally derived from actually kind of the mathematical functions. In mathematical functions, there are one-wave functions, especially these are used in cryptography. And these functions, it is easy to go from X to Y, but it is difficult in terms of the computational time to go from Y to X, so that the inverse operation is computationally very difficult, but still, of course, possible. If you figure out the function, then of course you can break the code so that that is not good for the security of the system. And the concept originally developed by Dr. Papo in MIT, actually, the physical one-wave functions, introduced an interesting concept where the use of physical systems rather than the mathematical functions, and referred as either physical one-wave function, but today most literature prefers still physically unclonable function name. And the idea here is you challenge a physical system, and the physical system gives you a response, like an output. But the key point here, the physical system is a stochastic system, and it gives you a random output, so that every time you challenge with a different challenge, of course, not the same challenge, it gives you a different response, different output, so that it gives you a unique response. So that is almost impossible or very difficult to replicate, duplicate, or clone, as the name suggests. So this is the concept that's attracting a lot of attention. Of course, physical systems in encoding is not new. And as I explore, I found this example, interesting example, I believe, as early as 3500 BC, people have used some cylinder steels, which has some complex, at least very complex for the time being, shapes, some schemes, so that they use these impressions as a measure of safety by just simply rolling that impression onto like a wet clay surface, for example. And now there's a lot of interest using such physical systems for security kind of applications. This is, I believe, a useful video from a company, because puffs have been used in electronic devices. So I'll just let you maybe see the video for a moment.
Physically unclonable functions, or PUF, are the digital fingerprints of electronic devices that can serve as unique identifiers to authenticate and secure devices. Imagine two identical phones. How could you tell them apart? By measuring small electrical differences occurring at the chip level. A fingerprint could be made of each phone. These differences occur because of variations in the silicon when the chips are manufactured. This is called an SRAM PUF, and is the most common type of PUF today. PUFs are a low-cost method of authenticating devices, generating and storing cryptographic keys, and generating random numbers. With the explosion of IoT devices, physically unplayable functions have the possibility to help create a root of trust that allows for low-cost device identification. For utilities, this means a way to trust and secure grid-edge devices, such as photovoltaic inverters, car chargers, revenue meters, and even substation relays. PUFs are one of many technologies that EPRI is exploring to help secure the integrated grid of tomorrow.
So I think this is a good description of using such physical unclonable functions and electronic devices. Actually, this has been already commercialized with some companies. But in our cases, we are mostly exploring other than electronic devices. Still, electronic part is investigated by different researchers, but we will mostly be exploring different materials for applications other than electronic devices. But the concept, I believe, is shown nicely here. So as we come to our research, one process we found very useful in fabricating such unclonable surfaces is solid state dewetting. As you see here in this video, dewetting is a common actually problem. And it's basically disintegration of a film into discrete droplets, as you see in a nice video from another research group for a different purpose, not for unclonable surfaces, but just again, this is a nice video illustration of dewetting, as we are all familiar in our daily lives. What is interesting here is when the solid film loses the stability and forms structures, features such as these features are typically random and they are formed randomly on a surface. So this process attracted our attention, and we started thinking about, okay, can we use solid state dewetting as a mechanism of encoding? And this was one of our first papers in this unclonable surfaces, and particularly polymers are relatively easier to dewet in comparison to let's say metals, which have much higher melting temperatures. And polymers typically have glass transition temperatures at around 100 Celsius degrees, so it is relatively easy to dewet such polymer systems and form randomly positioned features. And this is I will go through our first study that we reported the use of physically unclonable surfaces via dewetting of polymer thin films. In this particular case, we first modified the surface of our solid substrate, the silicon substrate in this particular case, with polystyrene. This is accomplished by grafting polystyrene. This is a well-known process. Why we use polystyrene? Because it provides relatively low surface energy, because for dewetting to occur, you need a low surface energy. So it's thermodynamically, is easier to form to wet the subsequent film. And here we use a second polymer film, which is P2VP, which is poly-2-vinyl pyridine. We work a lot with this polymer in our research because of this pyridine group. It could be either poly-2-vinyl pyridine or poly-4-vinyl pyridine in some cases, but this pyridine group provides us a nice functionality so that later on we could bind different materials. I will show gold nanoparticles here, but later I will show, for example, quantum dots as well. And what happens when we heat this sample at modest temperatures and times, let's say 250 Celsius degree, 5 minutes, you can play with the time temperature. You can lower the temperature, increase the time, vice versa. What you end up with these randomly positioned polymer features. As you see, the optical microscope, SEM, and AFM images. These are nice dome-like three-dimensional structures. And even at this optical microscope image, at the first security layer is formed by these optical microscope image, because these are randomly positioned features. Let's say you take an image of these features and put in your database. At a later stage, when you wanted to authenticate your sample, the end user, for example, takes another image and compares with the image in the database. But using poly2 vinyl pyridine, we could add another security layer so that we make it much more complicated to duplicate. And we do this by using colloidal gold nanoparticles. Gold nanoparticles, particularly the stabilized gold nanoparticles we use here, selectively bind to the poly2 vinyl pyridine, but not the polystyrene, so that we could, either drop cast or immerse the substrate in this colloidal solution of nanoparticles, and then wash the sample afterwards, and we end up with selectively functionized features that are functionized with colloidal gold nanoparticles. You see the color change. The features become pinkish due to the color of the gold nanoparticles, and you can see in the SEM image there's very dense assembly of gold nanoparticles. Why we do this? We wanted to use as a second layer Raman spectroscopy, because the gold nanoparticles increase the Raman scattering and enable what we call a surface enhanced Raman scattering. So then by adding a tagged molecule, we can add another layer of security based on Raman spectroscopy. In this idea, the first layer is easy to authenticate by just an optical microscopy, even maybe using some handheld microscope. But the second layer, of course, is more complex, and it requires, like an instrument like a Raman microscope. And here are some additional data that shows the surface energy effect. The polystyrene has a surface energy around 40 millinewtons per meter, and P2B has a surface energy around 54 millinewtons per meter. So that when you heat the substrate, to minimize the energy of the system, we end up with divets of poly2 vinyl pyridine, as we show from this analysis. And as I wanted to note, P2EP provides a highly useful attachment chemistry we used in the past for different materials like silver nanoparticles, silver nanocubes, gold nanorods, platinum nanoparts, even some nanoplatelets, such as like the quantum dots nanoplatelets. All it's possible to use P2P with different types of nanomaterials. We studied the effect of the thickness of the poly2 vinyl pyridine. And then as you see it here, of course, the thickness of the film is directly related to the size and the spacing of the divided random features, as you see it here. And this is, I believe, nice, so that's depending on the application, depending on the need, you can either use the, more like the small features or more like large features. For example, the large features is useful when you wanted to authenticate your system using a portable tool like a smartphone, even or a handheld microscope. But the small ones are more difficult to replicate due to their sizes, so that they could be useful in that sense. And an important part is the authentication process. We used in this publication the conventional authentication process. What we do here is we fabricate some markers so that we determine the location where the user should take a image of the surface. And in this case, we simply showed this concept by sputtering copper film from a shadow mask, as you see this crossbar here. And what we do is we take an image of this part, and then we do some processing. For this purpose, we use some MATLAB software to binarize the image. Then we reduce the size of the image and end up with these binary keys, which consist of ones and zeros. And as a result, now our image is now converted to such binary bits so that we can generate keys for each sample, each, let's say, security label. Then we put them on a database so that at a later step, when a user wants to check the sample, the user takes another image and again, you convert it to the binary code and compare with the database, and if they are the same, you say authentic, or if not, you say it's a false product, for example. This is the conventional way, but I will show other ways later to do this kind of authentication. And we do some analysis of the randomness mostly. I will not spend too much time on this. Uniformity is a measure of the random distribution of 0 bits, 1 bits. It's similar to, the chance of having heads and tails in unbiased coin flipping. And our data shows we are close to 0.5, which is the ideal value. Uniqueness is the ability of differentiating a key from other set of keys, because this is also very important for this application. And again, this is based on the Hamming distance concept. The Hamming distance is basically the number of bits with a different response when you compare the keys, like you see an example here with names, but we do the same thing with the binary keys. And again, ideal value is 0.5. What we typically find is some values around 0.5. This one's about 0.47, for example. So it shows it's okay to use such system in physical unclonable function applications. And we also do some other tests for randomness, especially the National Institute of Standards has a test suite for randomness, and we typically use also check the randomness of the binary keys by using those tests. And for the second security layer, as I told, we use surface enhanced Raman scattering, and we check different size of nanoparticles. We found, the highest signals in 10 nanometer. Also, we investigated the duration of the treatment with nanoparticles, and 24 hours seems to be highest, gave us the highest intensity. So we used those in our study, and these conditions enhances the Raman signal the most. And as just a proof of the concept, we studied with 3 different Tegant molecules. These are the typical Tegant molecules used in search studies, like rhodanine 6G, methylene blue, and erythrocin. And as you see, it's here, only when you select the right Raman shift, you see this image in each Tegant molecule. And in principle, you can increase this. There are examples in the literature up to 10 different Tegant molecules. So it's possible to generate much higher encoding capacities using this concept. And we also showed here by combining some patterning process, we can have first example of a hybrid security labels where we can control the randomly positioned features. For this purpose, we use selective UV ozone treatment. So we modify the surface energy of our substrate at certain regions so that de-wetting only occurred at certain regions. As you see it here in the crossbar region, there is no de-wetting, but other regions had de-wetting so that we could control the location of de-wetted features. And we studied the stability of physically unclonable functions. This is becoming more and more important as more publications are coming in this direction. When we did this work, there were very few publications investigating the stability for such a long time scale. But now we see people more and more investigating this. And I can say up to 1 year, we see a relatively good stability. And we studied stability of the polymers, which was, there's no problem, it was very stable. After you add the nanoparticle, we see in terms of the Raman spectroscopy, Raman signals, we see a slight decay, but still you can differentiate, distinguish the patterns. And even if you add the tagant and wait for a year, still you can see the signals, even though there is some decrease in the Raman instances. But I believe this is important and of course deserves more attention to further improve the stability of the physically unclonable functions. In a related work, through a collaboration with another professor in Turkey, Professor Hakan Usta, we investigated different material system, that is fluorescent organic semiconductors. This is a synthesized organic molecule which has been optimized, which has optimized optical properties, has nice, high quantum yields, very specific photoluminescence with low full width at half maximum. Well, it has certain lifetime dynamics as well. So using this system, we could also generate random features, and in this case, even as these are small molecules relative to polymers, it was relatively easier to generate divided features. And you see it here, you just spin coat or drop cast and just a brief thermal annealing, you end up such random features as you see it here. And other than the optical microscope image, these materials have distinct photoluminescence, distinct lifetime, distinct Raman, and even infrared spectra. So using such engineered molecule, I think was also useful for such applications because the molecule itself has very unique properties other than the randomness of the features. And these are some examples. Due to the ease of application, this material, we could apply it to some goods on paper, like the banknote, for example. So you could easily generate these randomly positioned features, and this is called as organic light emitting physically unclonable functions, which we refer as OLE-PUF, inspired from the OLEDs that are used in display applications. And we investigated some contamination cleaning, and at least at the primitive experiments, these labels were fine, stable enough for such applications. And another example I will give you, I think I still have some time. Again, this is a very recent publication. We have a joint project with Professor Jean-Pierre Ye at South Korea Inha University. They have expertise in graphene, and we use fabricated graphene-based unclonable surfaces. In this case, what we did was we used two sources of randomness. The first source of randomness emerged from CVD. We intentionally studied chemical vapor deposition conditions to generate multiple layers of graphene. This is maybe counterintuitive. People typically try to generate homogeneous film of graphene, but in this particular case, we intentionally generate a surface which has, as you see it here, different layers of graphene, because each graphene with different layers have different response in Raman spectroscopy, so that these are the Raman mapping image. Then we could generate multicolor Raman mapping image when you have different layers of graphene randomly positioned on the surface. We again benefited from the solid state dividing of polymers to pattern graphene. So to further increase the randomness of the process and also to make it possible to generate such multicolor image. Such multicolor is important for increasing, let's say, the encoding capacity and making more difficult to duplication. The final part, I would like to discuss a little bit about the use of electrohydrodynamic instabilities for fabricating such features. In the first example, we use electrospraying of polymers and particularly bulk polymers, so that's low cost actually. And this is also a very effective method and relatively easy method actually to apply, so that you could easily generate multiple polymers, random features of multiple polymers. They could not just only get random positions, but they could also get some complex features, even though it is difficult to authenticate such complex features, but also you can add fluorescent or other types of molecules so that you get specific signal from the surface. And in this particular case, we also use some other ways of authentication that I talked earlier. This is using some feature matching algorithms. So that you do not need to binarize your codes, rather you can use these algorithms that automatically, authenticate if the image is the correct image from your database or it's not the correct image. This is just an example. The yellow lines here show the matching points. And this is just an example on a smartphone, as you see it here, that you can apply such codes on objects such as a smartphone. Okay, and again, this is work that is under review. Again, using electrospraying, but this time with different quantum dots. And particularly we used with different sizes and geometries of quantum dots. The dotting rod is an interesting geometry. We collaborated with Professor Shim at University of Illinois. And this is again using electrospraying and the tattoo approach together. And as you can see now, we can generate these multicolor fluorescent physically unclonable functions. And in this particular case, we use a handheld microscope because for practical usage, using a heavy bulky instrument is not easy. So, but we could show we can effectively generate keys of multicolors and apply on the different objects and authenticate with a portable microscope. And the very last part of my talk, we also are working on hybrid approaches where we combine deterministic and stochastic approach on the same platform. And one method that we use in our laboratory is electrohydrodynamic jet printing. This is a high resolution printing system. These are some work that earlier work that I actually worked in the system. These publications are from my postdoc work on fabricating different types of patterns for different applications. So we are also exploring this electrohydrodynamic process to fabricate hybrid security labels. I believe a good example is here. This is also very, very recent work, just accepted for publication in Small. Again, this is a collaborative work with Professor Shim at University of Illinois at Urbana-Champaign. They have expertise in quantum dots. What we do it here is, depending on the pH of the solution, we could either generate deterministic labels, or at low pHs, we have seen some interesting disintegration of patterns where we could use it as a way to generate both the deterministic and stochastic labels. I think a good example is in my next slides. For example, we could generate such arrays of quantum dots. The location of the quantum dots is defined by EJet printing, so that is the deterministic part. But within that pattern, we have random features of different colors. And even you could further do this with some complex shapes. Let's say you have a bird image here. at a low magnification, you see bird, but when you zoom in, you see the random features within the bird, and with using like feature matching algorithms, you can check the, if there's a real bird or not, it's a fake bird, for example, so that you authenticate your sample. And again, we are also exploring other types of materials. I believe this is also an interesting case for drug safety and even the food safety. I think these are becoming more and more important as counterfeit medications and foods are resulting in health problems. A tragic example is related to the, counterfeit malaria and pneumonia medications. This is well reported in the literature, for example. So that for these kind of applications, you need edible materials. Like say, for example, quantum dots are no more useful for such application. With this motivation, recently we developed food grade physically unclonable functions. The inspiration comes from this kind of cookies with unique morphology. Actually, only the cornstarch containing cookies have this kind of morphology, and the cornstarch is actually interesting microscale material. It has couple of micrometers of diameter, but also it has nice size and shape polydispersity for this application. It has particle structure. Also, it's a good adsorbent, so that you can absorb different dye molecules. For this work, we use the food dye to get fluorescent images, and it's very low cost. It's widely available. People are using these materials for baking all the time. So this is another example. This, I think, shows that there's a lot of opportunities in this field to fabricate different types of unclonable surfaces. And these are some of those results that we show effective adsorption of this FDA-approved food colorants erythrocin B. We studied the biocompatibility as expected. They are very biocompatible materials, and we could get nice and good unclonable function performance. And we could also use the feature matching algorithms effectively to authenticate such systems. With that, I would like to conclude. I believe encoded surfaces show great promise for different applications, and particularly different types of instabilities, I think, are of interest. I'm sure there are many other types of processes, instabilities that are useful for such applications, and particularly integrating different types of materials with unique, photonic, electrical, magnetic, thermal, other properties seem to be interesting for future research. With that, I would like to thank you again for this nice invitation, and for the audience for their attention.
Thank you, sir, for this wonderful lecture. Are there any questions from the audience? If there are any questions, you can post it in the chat box. Okay, I don't feel there are any questions, sir. Thank you very much, sir, for being with us and enlightening us on this topic.
Thank you. Thank you.
Thank you. So let us start with the next session. We all will be with, the next session will be our technical session, that is related to the oral presentation. This will be headed by Dr. Sibling Matenapar sir, Assistant Professor, KD Societies, BK College, Chikodi. Before we start, I would like to give some general instructions. To begin with, the person to present during the presentation will be Before we start, the general instructions are the time allotted for the original presentation is 5 minutes, which will be divided as 4 plus 1. That is 4 minutes will be the presentation and 1 minute will be given for the question answer session. So you kindly restrict your presentation for 4 plus 1. The first candidate who will be presenting the oral presentation is Raja Ramakrishna. Next person will be posted in the chat box. You need to be prepared for the presentation. I hand over the session to Dr. Sibling sir. Sir, please carry on.
Thank you. At the outset, I would like to thank KD Society, PC Jogging Science College Hubli for organizing the mega event one day online international conference on recent trends in advanced material. So I am heading these oral presentations, and totally we have around 16 presentations in these hours. If I each already they have given the details about the presentations. Now I call Dr. R. Raja Ramakrishna for his presentation, and the title of the paper is Recent Developments of Advanced Luminescent Glasses for Reddish Orange Emitting Device Applications. Dr. Raja Ramana, please join.
Thank you, Dr. Siddhalinga Matapna. Can you allow me to share my screen?
Yes.
Yes, we are allowing to share your screen, and your time starts once you start sharing your screen.
Okay, the timing is very limited. Okay.
So you are visible to us. The only thing you have to share your screen. It's not possible from your end.
Oh, okay. Okay. So welcome to everybody. This is Dr. Raja Ramakrishna, head of the Glass Laboratory in Siberian Federal University. My topic will be on recent developments of advanced luminescent glasses for reddish orange light emitting devices applications. So the content of my talk today will be on a little background of why we have chosen this concept and introduction, and there will be a review on different glass formers, and I'm going to give the summary and conclusion. So here I am staying at the outset of a very Arctic part of the world, in Krasnoyarsk. So this is my university where I do my research, and this is a nightlife on which we have a maximum temperature of +30 and minimum is -25 degrees Celsius. Anyway, let us begin with the introduction part. Everybody are aware of this particular concept, electromagnetic spectrum, and I believe everyone is a physics background and a scientific outside. So everybody knows about this concept. So here, what we choose is we only choose about the particular electromagnetic radiation, which is around IR and visible. So the one which we choose is around visible spectrum, which is transformed violet to red, and the IR rays, which we use as for our criteria. So the energy depending wavelength is the one which we're going to use. So based on the energy and wavelength, so we're going to excite certain electrons or atom, and we're going to get some property out of that particular excitation. So the topic chosen is glass. So the glass definition goes as an inorganic product of fusion which has been cooled to rigid condition without crystallization. Is an American Society of Testing Materials standard definition. And it is also been given by my supervisor that glass is an amorphous solid which exhibits glass transition temperature by arresting the kinetics below supercooled liquid region when bypass crystallization, which is approved by the science direct society, scientific research society. So all we know that how the glass is being formed. So it's an amorphous solid, non-crystalline in nature, which lacks the long-range order of atoms. So they don't show any order. So molecular arrangement will not be available in this particular set of materials, and which is very huge advantage for us to develop certain things which we actually require. And they do possess certain phonon energy or thermal. They do possess some energy in the form of thermal, which is nothing but a phonon concept, phonon energy. So when it comes to different glasses, basically they have been classified in 6 to 7 glass formers: borate, phosphate, silicate, germanate, tellurite, and garnet. So fluorophosphate is recently added part. So we focus on 4 glass formers: borate, phosphate, silicate, and tellurite in this particular topic. And we also need to know how the glasses can be formed based on the trigon, what we call it as the triad series base. So in general, to mix any particular transitions element or rare earth transition elements, we need to focus on particular scenarios. So in general, rare earths are believed to show a prominent or significant future which has a 4f transitions, or what we call luminescent characteristics. So due to their inner transition elements, which are shielded by outermost d orbital elements. So when we consider with the lanthanum to lutetium, so we do have the ground state transition. So the ground state transition starts from 1s0 to it goes up to 1s0 of lutetium. So we focus on samarium part here, which is 6H5/2 of the series. These are all, I'll just skip the electronic configuration. The application part, I'll come to the application part. The application of this rare earth doped in glasses shows in various fields: solid state lasers, phosphor, optical fiber amplifiers, optical storage materials, light converters, sensors, acoustics, and 3D waveguides. So we focus on optical fiber amplifiers or optical fibers as such.
Mr. Rajamakrishna, your 4 minutes have been over, so please conclude it.
Okay, so okay, I'll just skip this. I just need to show that the laser guided communication can be done in the submarines using the samarium doped glasses. So based on this aspect and the optical fiber, how they have been connected around the world, so we actually we do this cladding material by using samarium doped glasses. The main purpose of the work is to make sure that the cladding of this particular material is done by the samarium glasses. And again, we change the glass formers. So I'll just skip this because it takes time. So the typical glass formation. So we use the furnace and we melt the at high temperatures, and we produce our glasses in the various forms. So one such glass is gadolinium borate glasses doped with samarium. So when these glasses are used and observed with the absorption spectra and emission spectra, we do observe a 600 nanometer, 563, 600, and 645 nanometer, and 705. So these are the main transitions which we observe from the samarium, which shows. Okay, so
kindly conclude, sir.
The conclusion of this is based on the various glass formers. So how can we retrieve or how can we extract the values which can be used for application orientation? I mean, how do we apply these glasses into the commercial purpose? So we compare with the commercial glasses available in the street and in the commercial available in the industries, and we make sure the optimization of these values can be done, and which will be used in the industrial purposes, which is already in success. Yes, thank you.
Thank you, sir. Dr. Siblin, sir, any questions from your side?
No questions. Thank you.
No questions. Okay, sir. Thank you. The next presentation will be.
Yeah, the next presentation is Sevda Etimani. The topic of the paper is evaluation of the electrochemical attributes of dual functional nickel oxide and bismuth chloride hybrid seeing operational potential.
Excuse me, sir. The next presentation is of Srinivas NV.
Srinivas, okay.
Yes,
The
Srinivas
next,
NV.
yeah. So the title of the presenter is Synthesis and Characterization of Nickel Oxide Thin Films by Spin Coating Technique. So Srinivas, please proceed.
Yes, sir.
Please restrict your presentation for 4 minutes. After that, we will be stopping your screen
It's
share.
visible, ma'am. My slide
Yes,
is
yes, you
visible.
are. Yeah, you are visible.
Okay. Good afternoon to all. Myself, Srinivas Envi, research scholar, Bangalore University, Department of Physics, worked under the guidance of Professor Vishwanath Envi, sir. Today, my topic is synthesis and characterization of gadolinium doped nickel oxide thin films. These are the contents: introduction, method of preparation, result and discussions, and conclusion. Nowadays, the metal oxides plays a major role for various device applications such as batteries, sensors, supercapacitors, photocatalysis, smart windows, and solar cells. Among these metal oxides, NiO is one of the most P-type semiconductor with a wide bandgap of 3.6 to 4 electron volt, high specific large surface area, and high stable material. In the NiO, nickel vacancies and oxygen interstitials are play a major role for suitable device applications. But in this work, we have taken the rare earth element, that is gadolinium, doped into the NiO thin films by using the solder spin coating technique. This is a method of preparation. I have prepared the 3 solutions, that is pure and 2% gadolinium doped and 4% gadolinium doped solutions. And these solutions are mixed homogeneously by using magnetic stirrer. And the prepared solution kept aging for 48 hours and coated on a clean glass substrate by using the spin NXG P1 spin coater. And after one coating, we going for preheating process to remove the solvent molecules and improve the crystallinity of the film. Like that, we repeat the process of 10 times to get the desired thickness of the thin film. And these 3 figures are the 3 thin films, that is pure 2% and 4% of those thin films. And the prepared thin films are characterized by using the XRD, visible Raman, and FPR technique. This is an XRD spectra of pure and gadolinium doped NiO thin films. These are oriented in the direction of 111, 200, and 220 with JCPDS number 780643. They have face-centered cubic structure, and the crystallinity should be decreases with increasing the dopant concentration we have observed. And there is a shift in the peak position, that is 200 peak we have observed here. That may suggested that there is an incorporation of GD into the NiO host lattice. By using Scherer equation and interplanar distance equation and cell volume, we have calculated the structural parameter. And this is an ritual refinement analysis of pure and doped NiO thin films. By using this analysis also, we have calculated the cell volume and lattice parameter value. These are the structural parameter values. And the stretch size is decreased with increase in the concentration of GD. And also the dislocation density should be increased due to there is a change in the lattice disorder in the prepared films. And the lattice parameter value should be increased due to the variation of ionic radius of Ni2+ and GD2+. GD has 0.96 angstrom and Ni has 0.69 angstrom. And next we go for Raman spectroscopy. We have observed the wave number range of 300 to 1000 per centimeter range, and there is a peaks in the around 400 and 500 range is due to the first order longitudinal modes of vibration of longitudinal and transverse modes of vibrations of surface nickel defects and Ni points defects, and the 589 per centimeter due to the both combination of LO and TO modes of vibrations. And for there is no secondary peaks we have observed here. That is, but there is a shift in the peak position we have observed that may suggest that there is an incorporation of GD here I have written, but there is a spelling mistake. GD is incorporated in the host lattice. And from come to the FPR analysis also, we have observed the nickel and oxygen absorption modes of vibrations in the transmittance mode. Observed bands we have observed, and the peaks at 878 and 1164 due to the carboxylate group present that may be accumulated during the preparation carbon groups on the surface. And there is a water content present on the surface of the film. We observed around 3000 per centimeter range. And we come to the UV visible analysis. The transmittance should be higher for pure and doped films also. The average transmittance we have observed around 90%. And the absorbance is complementary to the transmittance. And the optical band gap we have calculated by using the top plot relations. The optical band gap should be increased with increasing the dopant concentration we have observed.
And from XRD also we confirmed that due to the quantum confinement effect, there is an increase in the optical band gap value with decrease in the particle size. And also Arbeich energy value we have calculated, that is due to the surface defects and crystal imperfection and the prepared village, that Arbeich energy is inversely related to the optical band gap value. By using these structural optical studies, we confirm that the prepared samples are useful for optoelectronic device application and also transparent conducting oxide applications. Thank you, sir.
Yeah, thank you, Srinivas. Srinivas, I have one question.
Yes, sir.
These are the thin film samples, right?
Yes, sir. Yes.
Yes, but for thin films, generally reticle refinement is not reliable. People say, what is your comment
Yes,
on that?
we can able to do, sir, that one also, for reticle refinement also, it's possible.
But the lattice parameters, what you quoted, they are well matching with the reported ones?
Yes, sir, but they are a little bit smaller as compared to standard value. That is 4.17, but here I got 4.136 something.
The one nickel oxide you are saying?
Yes, sir, yes.
So any other questions from the participants? Okay,
thank you,
so
sir.
if there is no questions, let's thank the speaker and let's move to the next speaker.
Sir, nickel oxide. Hello, excuse me, sir. Hello, sir.
Yes,
Hello.
yes, please.
Sir, sir can use the nickel oxide and through the nickel oxide we can be study electrical property.
Yes, sir. We can study by using IV characteristics. We can study.
And TEM are not needed.
Yeah, that is also necessary for a surface morphology. We can study, no?
The surface morphology also. Okay,
Yes,
okay, sir. Okay, thanks.
That may be useful for gas sensing and something photo detector applications.
Sir. Sensing.
Yeah.
Okay, sir. Thank you. Sir.
But sir, energy gap is more.
Yes, sir. It's a wide band gap p-type semiconductor.
If it is wide band gap, why use the electrical conductivity?
We can
the
study
electrical conductivity. Sir.
Yes, tell me.
Sir. Yes, sir.
Okay. If there is no questions, let's move to the next speaker. Is there N. Chaudhary? Chowda Reddy?
Yes, sir. I am present, sir.
Yeah. The title of the presentation is Enhanced Near Infrared Photoluminescence Neodymium 3+ ions doped in borate glasses containing silver nanoparticles.
Yes, so excuse me, sir.
Please, N.
There's
Chaudhary.
change sir, siblings, sir. There is change in the allotment, sir. The next person who will be presenting is Sevda Etiman. He is sharing his screen.
Sevda Etiman is there?
Yeah, sir.
Hello, sir. Sir, my presentation is remaining, sir.
Yes, we will give you later chance. So now the presenter is Sevda. So please proceed.
Okay, I am going to start. Is it okay?
Yes, okay, ma'am. Start.
Okay. Hello, welcome. This is Sevda Etiman from Turkey Erciyes University Nanoscience and Nanotechnology Department. My presentation is going to be about zinc ion hyperspark. Sorry. My presentation is going to be about zinc ion capacitor performance of a multifunctional electrode material composed of nickel oxide and bismuth chloride. Professor Anses and Professor Şahmetlioglu are my supervisor and co-supervisor respectively. As known, supercapacitors are one of the most used electric energy storage devices like batteries and solid oxide fuel cells. Although there are similarities between supercapacitors and batteries, supercapacitors differ from other kind of energy storage devices by almost having a limitless lifespan and higher power density. But when it is necessary to use high energy density, there's a requirement to use hybrid system. When we check the physical background to enhance the energy density, it is necessary to boost the working potential window. Therefore, recently developed zinc-ion hybrid capacitors comes to the forefront by combining a battery type anode material like zinc foil and another capacitive type materials like conductive polymers or metal oxide, metal sulfides, or other kind of composites. Therefore, there might be numerous kind of materials to be used, like carbon materials and carbon composite with other kind of materials, conductive polymers, or other type of hybrid materials. Herein, we prefer to use nickel oxide and zinc oxychloride combination because these both materials have facile synthesis routes with different morphologies, and both of them again non-toxic structure. Additionally, bismuth-based materials can be used. Bismuth-based materials can be used as alternative anodic materials to the carbon-based materials. When we check the characterization results, we can say that the Princeton materials XRD and FTR results were compatible with the literature. Additionally, the composite materials also shows all of the peaks of the Princeton materials. When we check the scanning electron microscope results, figure A presents the images of bismuth oxychloride as flower and ultralight structure. Figure B shows the composite materials. As seen, nickel oxide small particles and aggregated intertwined particles are placed on the layers of the bismuth oxychloride. Additionally, elemental images also show all of the elements were including on the composite. We prepared the electrode by using 85% of active material, 10% of activated carbon, and 5% of PVDF on 1 centimeter square nickel foam. When we check the electrochemical results, figure A and B shows cyclic voltammetry results of the electrodes. Figure A shows the CV results of pristine nickel oxide when there is just two reduction and oxidation peaks. Figure B shows the composite materials results. As clearly seen, the composite materials shows two oxidation and two reduction peaks, indicating the composite has both anodic and cathodic features. Figure C and D shows the galvanistic charge discharge curves of the materials. And as seen, figure C, pristine nickel oxide has...
Madam, kindly conclude. You have crossed your 4 minutes time.
Okay, I am going to finish. As seen, figure B, C, and D, galvanic charge discharge curve seen, and composite material shows higher charge and discharge times. To check the practical application, we use zinc foil as anode and the composite material as cathode. Therefore, the device was able to reach up to 1.9 volts with a high specific capacity. And when we check the Ragon plot of the device, figure D, it can be said that the device was able to reach higher power density than a supercapacitor and a higher energy density than a lithium-ion battery. To sum, the characterization results were compatible with the literature, and we able to obtain a high power with good cyclic stability, with boosted potential window, and high energy and power densities were obtained. Thanks for your attention.
Thank you, ma'am. So, question from your side? Sejin, sir, any questions from your side?
No, I don't have any questions. Please proceed.
Okay, sir. Then we move forward. The next presenter is Bhavik Thakur. His topic is structural, vibrational, thermophysical, and electronic properties of full Hissler compound. So you kindly share your screen.
My screen is
So your
visible
time
also.
starts.
So good afternoon, all of you. My name is Bhavik Thakur. I am from the College University, Baroda, Gujarat. Structure vibrational thermophysical and electronic properties is a full Hissler compound, L10 phase, FeNiGe2. Now, this is the outline of the presentation. So over here, introduction, right? So Hissler compound is basically from the two transition element and one of the P block element that is known as the Hissler compound, right? If it is a half Hissler compound, the composition is X, Y, and Z form. First of all, introduced in the 1903, and the application of that compound is including the sensor energy harvesting and all the things over present over here. Now, the motivation behind the calculation is the paucity of the thermophysical properties, namely pressure parameter, debate of the specific rights of the coefficient of thermal expansion has boosted for the present investigation, paucity of vibrational property and Fermi surface that gives the electronic property and dynamical stability of the material. Right here in the computational methodology we used, right? Quantum expressor is the computational tools that calculate with the help of the PIW pseudo potential. And for thermophysical, we calculate the Gibbs program. So over here is the structural property of that material, that is the crystal structure, that is the FeNi2Ge, L10 phase tetrapolar machine, right? There is another structure is presented is L21 FeNiGe2, that is comparison with the next work. So over here is the lattice parameter that is highly coincide with the other presented parameter over here, and that is the tetragonal structure, and C by A ratio is highly coincide with the reported work. Now here is the electronic belt structure of the material, and these are the partial density of state that contribute the orbital in the density state that is highly coincide with that thing. Here are the Fermi level, and that bands are crossing the Fermi level. It shows that our structure and a zero temperature is metallic in the nature, and if the temperature is increasing, it shows the semiconductor in the nature. That is the speciality of half superconductor and full superconductor compound. Now here are the electronic charge density of there. So from the data, where is the red part is the load and charge interaction between that material, and where is the purple part shows, right? It is in the high concentration of the charge over there from that figure. Now here are the Fermi level of that thing. So band 9 and 10 both having the same value of the Fermi level, and they are crossing at the point of gamma from the pillar zone. Over here in the band 11 and 12 as in the center and closed shape is there. It means it shows the hole like Fermi surface. Over here in the band 13 and 14 it shows the electron like Fermi surface that are basically crossed in the M to the path of A, and over here in the R point of the pillar zone. You can see in the figure number 13 and 14 with reference of the pillar zone. Now next is the merged Fermi surface that is shows in the electron type Fermi surface that shows the metallic in the nature again. Now over here the vibrational property of the material, that optical and acoustic phonon branches of the all the things are disappear with highly coincide with the phonon density of state, and phonon frequency is positive. It means it is shows the dynamical stability of that L10 FeNi2Ge structure is there. Now over here the room temperature equation of state, over here with the help of temperature, volume is decreasing with the help of the temperature. We go for the 40 gigapascal. Now here thermal bulk modulus is there. That is nearly approximately the 500. A coefficient of thermal expansion. So whenever we are increasing the temperature, very low rate of coefficient of thermal expansion that shows the inward property of that material. Over here is the CPCV is there. Slightly volume of that material is increasing with the help of the pressure. Now over here is the temperature dependency is there. When the higher is the temperature, the dependency of the material is gradually decreasing, and over here is the Gunnar-Shah parameter that shows, right, whenever the P is equal to 0, temperature is increasing, right? Gunnar-Shah parameter is the constant thing. Here are the conclusion of my topics. Let us constant of L10 and right, we got good agreement with the reported data. Band structure shows the metallic in the nature. Charge density shows the distribution of charge in a crystal structure. Fermi level gives the idea about the electron type and hole type of that material. Phonon dispersion and PDOS shows the dynamical stability of the materials. And here most important part is the thermophysical properties. These are the another reference I used for that studies. Thank you.
Thank you, sir. You have completed your presentation well within the time. Shiblin, sir, any questions
Thank
from
you,
your side?
How you are expecting the synthesis of this sample?
Yes, sir.
The experimental data, if we want to compare. Hello. Can you hear me?
Yes, sir, I am hearing you, sir.
Yes. So have you synthesized this compound? Not yet, right? You are done only theoretical studies.
Yes, sir, I am using the DFT density functional theory, and I calculate that property of that material.
Yes.
Some of the properties like structural and magnetic properties already reported. On the basis of that, I calculate the other property with the help of the computational tool.
Okay. Thank you.
Thank you, sir. The next presenter is N. Choda Reddy. His topic is enhanced near-infrared photoluminescence, neodymium ions doped in borated glasses containing silver nanoparticles. Sir, kindly share your screen.
Madam, kindly allow me to share the screen.
So what's your ID? So what name you are using?
Choda Reddy, madam.
Choda Reddy. Kindly share your screen.
Yeah, madam. Good afternoon, one and all. So myself is Choda Reddy. So here I'm present research article entitled as the enhanced near infrared photoluminescence neodymium ion doped borated glasses containing silver nanoparticles. And these are the content I have. So I'm going to discuss. And because of that shortage of time, I'm skipping that introduction part and all. And directly, so I can start with the that is the methodology using. So here in my present research, I'm using a simple technique, that's a conventional metal quenching method I'm using. So in this method, I'm using that is a precursor powder of 99%, 99.99% purity of that the above combination of that combination of that mixtures. And so here I'm going to make it as a different batches, and each batch is containing a 30 gram of a finely powdered mixture was taken in the porcelain crucible and melted at 950 degrees Celsius for a 30 minutes time duration. And the molten liquid quenched, and that is quickly quenched on that is a preheated glass plate, and synthesize the glass were heated and treated at heat treated at 300 degrees Celsius for 3 hours to make the samples free from the thermal free from thermal stresses. And this is a very simple that is a method, the methodology I'm using. And so here, when I come to the the results, there is a results and discussion. So here, firstly, so first to confirm that what are the composition I have taken. So for that one, I have taken the FTIR. In this figure, the FTIR signature that is observed at a center of that's 1,364 per centimeter related to that trigonal unit over to that is a stretched motion of the PO1 in the glass structure, and the diffused band that is operated at the center of the 1,244 per centimeter was caused by the stretching motion of the PO bond and existing in PO3 2- group of the metaborate and orthoborate structural groups. And here, so here the TEM images to the silver 0.2 glass, the sample is depicted in a figure A, and the histogram shows the size variation of the silver nanoparticle with the specimen is provided in the whatever the specimen, the figure A provided. So with the same thing we have conveyed in the uniform distribution with the histogram, and the variation of the size and the median size of the silver nanoparticles were analyzed so that the image that software, and micrograph in a figure A reveals that the silver 0.2 glass is embedded with the spherical shaped silver nanoparticle distribution homogeneously throughout the specimen. And here, when you look into the absorption, that is the optical absorption and the photoluminescence attribution. And so here, so in this figure, so clearly shows that the optical absorption, the spectral outcome of the neodymium 1 and silver 0.2 and silver 0.6, and the HENOC that is containing the glasses showed a bored absorption band at that's 422 nanometer, the nanometer corresponding to the surface plasma peak of the silver nanoparticle. That is the keen observation of absorption the spectral results of the silver nanoparticle containing the glass that reveal that that's the SPR peak of the position is the red shifted from the 422 to 436 nanometer with the increase of the silver nanoparticles, the concentration from 0.2 to the 0.6 the molar percentage. And so here when you come to the near infrared emission, so here the luminescence enhanced factor for photoluminescence emission, the peak located at the 1000.
So kindly conclude your
sure. So located at the 1065 nanometer was that is enhanced for 1.33 to 2.53. When the silver HENOC contains the increase from 0.2 to 0.6 molar motor, although that is LEF, the luminescence enhancement factor so decreases at 0.8 to 2.38 mole percentage. And so here, so finally, when we come to the conclusion, that is the FTIR, the FTIR spectral outcomes unveil the existence of the different BO3 and BO4 units in the glass structure, and the TEM micrograph reveals the formation of spectral shapes of the silver nanoparticles with a homogeneous distribution of the silver 0.3 glass with the particle diameter of 0.6 nanometer. And UV visible absorption results further confirm the formation of the silver nanoparticles by the demonstrating the SPR peak at the 422 nanometers. That's for silver 0.2 nanometer, 0.2 so percentage.
Sir, we have disconnected your screen.
Okay.
Sibling sir, any questions from you? Sibling sir, any question to the presenter? Sibling sir. Okay, maybe there is some network issue from sir side. We'll move ahead. The next presenter is Padmaja V. Her work entitles Graphene-based titanium oxide nanocomposite for the removal of antibiotics from aqueous media. Padmaja?
Hello, ma'am.
You can share your screen.
Okay.
Madam, your time starts now. You share your screen, madam.
Okay.
We are not able to hear you. You unmute yourself.
Hello. Hello, ma'am.
Madam, we are not.
Hello, ma'am. Hello, ma'am.
Madam, what's the issue?
Hello. Madam, are you ready or shall we get back to you later? Hello, ma'am. I'm audible.
Yes, ma'am, you are audible. Please share your screen.
Okay, ma'am. Madam, my screen is shared, ma'am. Yeah, your screen is shared, madam. Hello, ma'am. Hello.
Ma'am, you can start now.
Okay, ma'am. Sir, my name is Padmaja, research scholar. My guide name is Sri Chandana, Professor Annamacharya Institute of Technology and Sciences. My topic is graphene-based AiO2 nano composite for the removal of antibiotic from aqueous media. So many emerging contaminants are present in the wastewater. So we are selecting the emerging contaminant from the pharmaceuticals. That pharmaceutical target compound is, my target compound is ciprofloxacin. This ciprofloxacin is antibiotics called fluoroquinolone. This is used for treatment of more antibiotics are used for bacterial infections. This ciprofloxacin is removed by using the separation process, by using adsorption and decomposition process, by using the GO and GOTIO2, graphene oxide and graphene titanium oxide. This is the attributes of graphene. By using this is by our selecting the means high surface area, absorption capacity, and electronic conductivity, 1 atom thickness. So we are selecting the graphene oxide and also graphene oxide and TiO2. The visible range is UV visible spectrum range ciprofloxacin is 280 nanometers. This is the antibiotic. By using samples prepared by graphene oxide is Hummer's method, and then GOTIO2 is Sol-Gel method. And then this is the fabrication of graphene. By using graphite powder, we are getting graphene oxide by using H2SO4, and then again our graphene oxide is converted into reduced graphene oxide by using ascorbic acid. Then these GO and GOTIO2 are characterized by using XRD and then SEM, then TEM. These are the graphs. Scanning electron microscope, SEM, GOTIO2, and then anticipated removal mechanism, ciprofloxacin by using this, adding the water, then separate the ciprofloxacin by using GOTIO2, then adsorbent capacity is find out, and then the removal capacity is find out. Then this is the transmission electron microscopy of the GO and GOTIO2. This is the pictures we got it. This is X-phase spectrometer. This is the binding capacity of the materials present in the GOTIO2. Bonding capacity is known for this XPS spectra. This is the ciprofloxacin calibration curve, absorbance calibration curve. Absorbent dosages we are using GO is 300 milligrams per liter and then 600 milligrams per liter for removal capacity. This is the graph shown by you. This is the ciprofloxacin 0.5 milligrams per liter and 1 gram milli per liter, 2 milligram per liter. GO is used for ciprofloxacin. The graph is using this one. This is the concentration of CIPS. We are used 5 milligram per liter and 10 milligrams per liter, 15 milligrams per liter. This is the removal difference between pH 1 gram liter per GO is used, 2 gram liter per GO used. There is a difference between the removal capacity. This is the TiO2, only TiO2. In TiO2 1 gram per liter and then 2 gram per liter. There is no difference in the graph. Removal absorption removal. This is we are using GOTIO2 0.5 gram per liter and 1 gram per liter, 2 gram per liter. In this graph, only 1 gram per liter and 2 gram per liter is more same absorption capacity is this. So ciprofloxacin is removed by GOTIO2 is the same in 1 gram per liter and 2 gram per liter. That is why most optimum dose is 1 gram per liter. This is the conclusion. So we are ciprofloxacin is more popular antibiotic we are using. So this is the present in the wastewater from the pharmaceutical companies. So by using graphene oxide and TiO2, more ciprofloxacin is removed by this adsorption process and photocatalysis process by using phase separation and then photocatalysis process by degradation of the ciprofloxacin. Thank you, sir. Thank you, ma'am. You have completed well within the time allotted to you.
Yes, Padmaja. Madam, have you done any sensor measurement on this compound?
What, sir?
Sensor sensitivity. Have you done any sensitivity measurement?
No, sir. Not done, sir.
Like this electrochemical workstation and all those things you have not done?
No, sir.
No, but that wastewater what you have used,
Hmm.
how you tested that? So is there any machine you use like electrochemical workstation for testing that? No.
Which, sir? Wastewater testing.
Wastewater, that wastewater you say no, this is
No, sir. We are taking normal water added to ciprofloxacin. That we are taking, sir. Sample
and
per
then
sample. Sir?
Yeah, then you combine, then you mix referred with the wastewater, pharmaceutical wastewater.
Yes, sir. Yes, sir.
Ma'am, I have a question.
Sir, ma'am.
Ma'am, what is the light source used? What is the wavelength?
280 nanometers, ma'am.
Light source? Light source, ma'am. Is it xenon or what kind of light source?
UV spectrophotometer, ma'am. Visible range UV spectrophotometer we are using, absorbance capacity.
Thank you.
Okay.
Thank you, ma'am. If anyone from the audience have questions, you can put it in the chat box. We will raise the question. Thank you, ma'am. Next one will be Lakshmi Ji Hatya. Her title will be Gas Sensing Application of Nanocrystalline Ferrites Synthesized by Citrate Gel Auto Combustion Method. Lakshmi, madam?
Yes, ma'am. I'm online.
You kindly share your screen.
Yes, ma'am.
Lakshmi, madam. Madam, are you there?
Yes, ma'am. I'm there. I'm sharing my screen.
I guess there is some network issue with Lakshmi, madam. We'll go further. The next presenter with us is Mr. Mahesh Bhatt. His work is entitled Synthesis of Titanium Dioxide Nanocomposite for the aqueous dye degradation.
Madam, please allow me to share the screen.
Yeah, so you can share your screen now.
Now is it okay, madam? It is visible?
Yes, it's visible. You can do it in the
My
slide share mode, sir. So please do convert it to slide share mode. Yeah, your time starts now.
Now is it okay, madam? Myself, Dr. Mahesh Bhatt, Assistant Professor working in the Pune Padma College, Udupi. My topic is synthesis of titanium dioxide, Fe2O3 PUA nanocomposite for the aqueous dye degradations. Regarding and the keywords, introduction. As the global population increases and as continues to grow, there is a leading to the environmental contaminations. Water bodies is one of the such a highly polluted area, and that pollution is included by the textile industries. In per annum, 7.5 metric tons of the dyes are added by the industries to the waters. So these dyes can easily degraded by the photocatalytic process by utilizing the various catalysts. Among them, titanium dioxide, zinc oxide, cerium dioxide, and bismuth compounds are the one of the such a photocatalyst useful for the degradation of the dyes. This degradation can also achieved by the organic pollutants and also pesticide, dyes, pharmaceutical and polycyclic aromatic compounds. And titanium dioxide is such one of the nanocomposites which has the high chemical stability, inexpensive and non-toxic. By including titanium dioxide with the polyvinyl alcohol nanocomposites, it is evaluated for the electrical properties and also applicable for the different fields. The thin film of the titanium dioxide doped with the polyvinyl composites decreases the band gap for the required band gap energy, that is 3.04 electron volts. Photo-oxidation is one of the very good method for the oxidation of the colorant, such as zinc, bismuth, titanium are used for the photocatalyst, and we can decrease the material cost also by increasing the surface area, so by converting into the nano particles, combinations of the nanomaterial into with the various oxides, we can achieve the good results. Objectives of the study is synthesis of the nanocomposites and characterization and photocatalytic activity on the synthesized nanocomposite. On the nowadays that the water pollution is very high. Water purification, so organic dyes are the carcinogenic and harmful to the both aquatic and non-aquatic living beings, non-aquatic thing and photocatalytic purpose. And wastewater we can purification in a large amount without requirement of the special technology. Then synthesis regarding the nanocomposites, 2.027 gram of the perchloride dissolved in the water and 2 gram of the titanium dioxide was added to this solution. 2.5 gram of the polyvinyl alcohol was added to the solution and stirred during the 1 hour, and 3 gram of the sodium hydroxide solution is added and continue for the stirring, and after precipitations the filtered and residue are collected and heated at about the 20 degrees Celsius in a hot air oven. Next thing is characterization through the semidex techniques, and next one is carry out the batch experiment for the study of the photocatalytic oxidation ability of the nanocomposites. So various techniques here, pH variations, dose variations, and time variations methods are followed. Initially 0.02 gram of the dye solution, that is congruent, is utilized for the this purpose of the study. It is dissolved in 2.2 ml of the water, and another dye, that is crystal violet and methyl red, are also utilized for the evaluation of the batch experiments. These are some of the results. In the Congo red dye undergo photocatalytic oxidation, photocatalytic degradations at the neutral pH, more compared to the other two pH. And in the case of the crystal violet, there's an acidic solution is good for the carry out the most percentage of the dye degradations. And in the case of the methyl red at the higher time, there's a basic conditions are the good for the carry out the photocatalytic degradation process. And this is a scanning electron microscope image of the synthesized nanocomposites. These are the references.
Sir, kindly conclude.
These are the references. These are the we are obtaining a good results regarding this photocatalytic oxidation process by synthesized nanocomposites. Thank you very much.
Thank you, sir. Okay, we'll move ahead. Lakshmi madam, have you joined back?
Yes, sir. Next.
Okay. The next person is Vijay Gupta. So are you here?
Yes, ma'am.
Yes.
Yeah.
So we'll be presenting on study of red.
I have uploaded only the abstract there, no? So that is there now, but later I uploaded the PPT now, and it has been turned on by your institutions now. So I will read it orally now, or only audio clip will be there. Is
So
it possible?
come again, sir. You have to present your PPT, sir. You have to
PPT.
share your screen.
Yeah.
So do you have your PPT with you?
PPT, I have the physical PPT is here now.
So you're not using your laptop for the presentation, sir?
Yeah.
Or is it soft copy do you have in your phone?
Yeah, soft copy I have.
So we'll do one thing, sir. We will connect to you. We will call you and talk to you. By then we will start with the next presentation, because or else there will be a time gap. Okay, we'll just call you.
Uploaded the PPT to your institution, ma'am, but that has been turned down now, because first I have loaded now the abstract, and then after PPT added 1 or 2 days after I uploaded it now.
Sir,
On the
please,
mail,
I
I
will
have
call you.
uploaded.
No, I will call you now, sir. We will discuss it. By then, we will start with the next presentation. Later, you can present it. Okay.
Okay.
Next presentation, you can do it. Yeah. By then, we will
Okay.
call you and contact you what to do. Yeah.
Okay.
The
Okay.
next
Thank you,
presenter
ma'am.
is Dr. Mamta AG.
Okay.
Dr. Mamta AG. Madam, are you
Ma'am,
there?
please, yeah, ma'am. Can you please allow me to share the
Madam,
PPT?
what is your name? What have you saved it as?
Pardon?
What have you saved your name as? Because we are not finding anything by name Mamta.
Okay, I have unmuted, ma'am. Can you please? Admin, I think so.
Mamta is not. Is it admin?
Admin, yeah.
Yeah. So search for the admin. Admin.
Admin.
Yes, ma'am. You can share your screen now.
Okay.
Ma'am, make it to slide share.
Sir, I can't do it.
Good afternoon, everyone.
Your
Today,
time
my
starts now.
presentation is on multi-band flag-shaped slotted printed antenna for wireless communication. So my presentation outlines our introduction, methodology, antenna design, results, and conclusion. So coming to the introduction, we all know wireless communication system has a signal transmission and reception is a very essential part. So in this, antenna plays a very important role. So we have many types of antenna, right from a small antenna to a large parabolic antenna. Among these, microstrip antenna plays a very important role because of its compact and the low profile, and it is a planar in nature. So microstrip antenna was proposed first by D. Chance in the year 1953, the first practical antenna later developed by Holman and Musin. So the patch antenna, that is a microstrip antenna, consists of two conducting plates separated by a dielectric material, and it is also known as printed antenna. Since it is a very planar in nature and low cost and easy for fabrication, it has numerous applications in the field of WiMAX, Wi-Fi, Bluetooth, and so on. So we have seen that one antenna can transmit in one frequency, but if I want to use 2 or 3 resonate frequency antennas for any systems, then I need 2 to 3 antennas. This will increase as a system size. So in the present work, I have concentrated regarding the multiband antenna, so that I can reduce the system size. The next is my methodology, what I have followed. So initially I have designed the antenna for the 3.5 gigahertz by using the equations which is available in the literature survey. Later I have chosen the substrates as the FO4, and the design antennas are being fed, and it is designed using the simulating software, that is HFSS, and later the simulated software design is sent for the fabrication, and it is optimized. Once it is fabricated, it is tested in the experimental results are being seen in the vector analyzer, and both the simulated and the experimental results are compared. So these are the equations which I have referred from the literature to design the antenna. And first, initially, I have designed a conventional antenna, which is for 3.5 gigahertz. Its structure and the fabricated design is shown in the figure, and its parameters have been tabulated in the tabular column. The antenna is resolved for 3.27 gigahertz with a written loss of minus 14.33 dB with a fractional bandwidth of 2.43, and which is showing a gain of 3 dB, and the radiation pattern shows broadside in nature. Next, I have used a technique called a simple, that is slot loaded techniques. The narrow rectangular slots are embedded on the radiating patch, and which is simulated using software, and which is showing a quad band in nature. So the simulated and the fabricated antenna is shown in the figure, and the length and the width of the slots are being tabulated in the tabular column. So the antenna is resonating at 4 different frequencies, that is 2.84, 2.80, 7.19, 9.22, and 12.93 gigahertz, which is having a very good written loss, having a fractional bandwidth, and the overall bandwidth of 23.8%, and it is having a gain of 5.6 dB, and it is also showing a virtual size reduction 17.64%. And its radiation pattern can be observed in the figure, that is, it's showing a broadside in nature with a higher copolar radiation as compared to the cross-polar, and the current distribution can be observed that we have a more current distribution near the feed line and as well as near the slot-loaded edges. And this antenna finds application in the radar, aeronautical, and Earth satellite communication. So when I compare this work with the existing work, it shows very good written loss, gain, bandwidth, and the number of bands. So I can say this antenna has a multi-band resonant frequencies. Thank you. These are the references. Thank you.
Thank you, madam. Next to present is Preeti BS.
Yes, ma'am.
Her topic is environmental pollution, a serious threat to global ecosystems.
Yes.
Madam, we have made you the co-host. You can share your screen.
Yes, ma'am. Good afternoon, everyone. Am I audible, ma'am? Yes.
Yeah, you're audible, madam. Your time starts now.
Yes, good afternoon, everyone. Myself, Preeti. I am the research scholar in JSS AHR Mysuru under the guidance of Shankarama K. So today I'm going to explain the wastewater treatment. So first of all, what is wastewater treatment? Wastewater is the term that is used to describe the waste material that includes industrial liquid waste and sewage that is collected in towns and urban areas, and treatment at urban wastewater. Then this is the slide explains the industrial wastewater treatment. So all the industries are the waste having a dyes. This dye is toxic effect on the environment and human health. We can treat this one minute. We can treat these dyes using these three treatments: biological treatment, physical treatment, and chemical treatment. So then it converted into a good water. So wastewater purification techniques are these are the wastewater purification techniques: absorption, biotechnology, nanophotocatalytic process, membrane process, ionizing radiation process, magnetically assisted process. Here I am going to explain the nanophotocatalytic process. So first, what is nanotechnology? Nanoscience and technology are the study and application of extremely small things, and it can be used across all other science fields such as chemistry, biology, physics, material science, and engineering. It conducted the nanoscales, which is about 1 to 100 nanometers. So nanotechnology in a wastewater treatment. So these nanoparticles have a great potential to be used in wastewater treatment. It is unique characteristic and high surface area, can be used efficiently for removing toxic metal ions, disease-causing microbes, organic and inorganic solids from the water. Various classes of nanomaterials already proved this. So, for metal-containing nanoparticles, carbonaceous nanomaterials, zolites, and dendramites are proved this. Then, nanotechnology has led to various efficient ways for treatment of wastewater in more precious and accurate way in both small and large scale. So these are the factors affected by the wastewater treatment. First one is biochemical oxygen demand. Second one is nitrate and phosphate are reduced, and we can remove the pathogens, and we can remove the metals, and we can remove the total suspected solids and total dissolved solids and synthetic chemicals. So the mechanism for removing pollutants, first one is nanosorption, second one is nanofiltration, and third one is photocatalysis. Nanosorption. Nanosorption means it having a large absorption area. So absorption is a surface process where these pollutants are absorbed on a solid surface. Usually nano absorbents are used to remove the inorganic and organic pollutants, and this has some unique characteristics such as a small size. It has a small size, catalytic potential, high reactivity, large surface area, and large number of active sites for interaction with different contaminants, make them ideal absorbent material for the treatment of wastewater. Then carbon-based nanoabsorbents, metal-based nanosorbents, polymetric nanosorbents, magnetic or non-magnetic oxide composite, and zeolites are currently used for wastewater treatment. The next one is nanofiltration. Nanofiltration is a pressure-driven membrane separation process falling between ultrafiltration and reverse osmosis. Nanofiltration membrane has a pore size of 1 to 5 nanometer. Nanofiltration membrane have been shown to remove turbidity, microorganisms, and inorganic and nitrates, arsenic from groundwater, organic pollutants. For example, carbon nanotube filters and nano ceramic filters. Then third one is photocatalysis. Photocatalysis is an advanced oxidation process which is based on oxidative elimination of micropollutants and micropathogens. Most organic pollutants can be degraded by heterogeneous photocatalysis. This is the diagram explains the photocatalysis. When we fall light to the photocatalyst, for example, TiO2. In the TiO2, we have a band gap. In a valence band we have electrons. When we follow light to the photocatalysis, the electron jump from valence band to the conduction band. Because of recombinations of holes and electrons, oxidation and reduction process is done. Then after that oxidation and reduction process, organic pollutants can be converted into amylase, and it can emit CO2 and H2O. It can be converted into CO2 and H2O. Then photocatalysis coupled with UV lights can oxidize organic pollutants into non-toxic materials such as CO2 and water. It can disinfect certain bacteria. This technology, yes ma'am. This is the mechanism of nanophoto. Yes ma'am. This is about the conclusion. To maintain a sustainable and clear environment for future generation, more research and application for such technology are very necessary. This is about the reference. Thank you, ma'am.
Thank you, madam.
Preeti, I have a question to you. What is your contribution? What work have you done?
Sir, just I review the papers because the last 3 months before itself I joined as a research scholar. So just I review the papers, sir. On the basis of review papers, I done this.
Oh, it's all existing. Okay. People have done work, and what is your contribution that needs to be presented? So it's only a research work, right? I mean, a review work.
Yes. Yes,
so
sir.
there's
Yes,
no
sir.
research
Review.
involved as such.
No, sir. No, sir.
Oh, thank you.
Okay, sir. Thank you, sir.
The next presenter is Aishwarya M. Mishrikoti. Madam, are you here? Aishwarya, madam? Yeah, okay, the next one is Vijay Kumar R. So kindly share your screen.
Okay. Okay, may I audible now? Yes. May I audible now?
Yes, sir. You can.
Myself, Vijay Kumar. I'm a research scholar from Bombay University. My father supervisor, Dr. Amit Yadav.
Sir, you convert it to slide share first, your presentation.
I'm editing now slides here.
No, sir. Full screen you make it, sir. No, sir. Beside the zoom option. Beside the zoom option, yes.
No.
Yes, that one only.
You click on that one, sir.
Yes, that one.
Variable, ma'am?
So it's maybe there's some network issue from your side, so you continue.
Yes, ma'am. Myself, Vijay Kumara from Bombay University, research scholar. My college supervisor is Dr. Abhi Padar. Today I'm going to explain the synthesis and structural analysis studies of graphene oxide. These are my outlines. Introduction about graphene oxide, experimental techniques, what I have done, and result of discussion. The first introduction started from the nanotechnology. Nanotechnology involves in designing and producing object or structure at very small scale, the level of 100 nanometer. And nanometers are one of the main products of nanotechnology: particles, tubes, rods, and 5% nanoparticles. And next we move on to this main topic is classification of nanomaterials. We have seen that there are major types of nanomaterials based on their size, shape, and the intrinsic property. Here the two types and the main materials based on categories and the dimension based on categories. And synthesis of nanomaterials. This synthesis of nanomaterials, we have clear two picture. One is top-down approaches and bottom-up approaches. And here top-down approaches is requires very new challenges to fabricate and developing any new devices. Whereas the bottom-up approach as the very essential for very essential, easy to make up of any nanomaterials. Now the main topic is graphene oxide, and graphene oxide has attracted great interest of excellent mechanical and theoretical thermal properties. And these are the most common derivative of graphene, consists of layered carbon networks and decorated with oxygen containing functional groups. And now we move on to the experimental preparation of graphene oxide nanoparticles. We have done here graphene oxide is prepared by Hamas method. As shown in the figure, the cities of graphene oxide, and we make a loss in a powder form of graphene oxide. We categorized main in three characterization. One is oxide diffraction, UV visible spectrometer analysis, and photoluminescence analysis. And in
your PPT slides are not moving, sir.
It's not showing in, sir. Now, sir.
Okay, make a slideshow, sir. Mostly it is a network issue.
So I've already done an. So it's showing, sir, in my laptop. Okay. So now, sir.
So make it a slideshow, sir.
Please conclude it.
Yes, sir. Sir, now,
sir, as there is as there is network issue at your side, you can please conclude your presentation orally.
From this project is we synthesized a few graphene oxide nanoparticles successfully by Hamas method, and we categorize that graphene nanoparticles in X-ray diffraction and we collected the size of the nanoparticles in the X-ray diffraction, and we see the intensity peaks of graphene nanoparticles in that X-ray diffraction, and then UV visible spectrometer analysis in that there is observed excitation peak of the graphene nanoparticles, which is in the blue shift. In the blue shift, we use different optical properties of graphene oxide nanoparticles. And the last one is the photoluminescence. In the photoluminescence, we calculated the band gap of graphene oxide nanoparticles, which is an average of 70 nanometer. And in that, by the using of the photoluminescence spectral analysis, we can analysis by the chromaticity diagram, in which chromaticity diagram we found that the graphenite nanoparticles are the coordinates in the green region. That green region shows that these all categorization is.
So your time is up, sir. Please wind it up. So your time is up.
Next candidate.
Okay, thank you, Anand.
Thank you, sir. The next candidate is Swati KM. Madam, are you here?
Yes, ma'am.
Other participants, please look into your network region so that there is no disturbance while you're presenting. Swati, ma'am, please share your screen.
Okay.
Share your screen, madam.
Ma'am, can you enable the HP name, ma'am, for sharing the screen? Because I'm using laptop and mobile both.
HP also we have to enable.
Yes, ma'am, for sharing the screen.
We have to enable HP. She's using mobile and laptop both.
HP.
Come again, ma'am. HP.
Yes, it's there. Okay.
Yeah, you can use, ma'am. You can share your screen now.
Okay, good afternoon. Good afternoon, I am Swati KM from PC Japan Science College.
Yeah, convert it to slide share, please. Slideshow.
Yes, ma'am.
Yeah.
Can I start?
Okay, you can start, ma'am. Your time starts now.
My topic is on application of cadmium doped cobalt chromates for enriched sensing properties and recovery time in humidity sensors. And the outline of my today's talk is introduction, rare earth doped chromates and its properties, applications of chromates, synthesis method of the cadmium doped chromates, results and discussion of cadmium doped chromate system. So while we go on to the introduction part, humidity sensors are used to achieve comfortable, safe and efficient environments, and they are mainly useful in electronic devices. There are three primary types of humidity sensors: capacitive, resistive and thermal. And in my present work, we have prepared cadmium doped cobalt chromate nanoparticles for humidity sensor applications. When we see the properties of cobalt chromate, the properties of these cobalt chromates are enhanced by rare earth ion cadmium as dopants, which cause significant changes due to the FF transitions inside or outside FD configurations. And they have high color purity, stable physical chemical properties, good resistance to high power electron beams, and restricted emission band spectra and high porous nature. The intriguing applications are like low corrosion, low cost, ease of preparation. They can be prepared very easily, lack of need of complicated tools, excellent workability, strong environmental stability, and distinctive transport features. And the motivation of today's topic is doping of rare earth metals cause significant changes in the properties of cobalt chromates that increases the applications in humidity sensors, which has given a lot of scientific attentions. Okay, how the synthesis part goes like: the stoichiometric molar amounts of cobalt nitrate, cadmium nitrate, and chromium nitrate were dissolved in 30 ml of water along with the fuels urea and glucose, and heated for about 30 minutes at 450 to 600 degrees Celsius. And it goes like, after the foam formation, the combustion takes place with the evolution of gases like nitrogen and water, and finally the powder is obtained. The powder was finally crushed to obtain the fine nanoparticles, cobalt chromate nanoparticles. And when we move on to the results and discussion, this first goes like XRD, the structure and phase analysis. The XRD patterns were recorded in 2 theta range from 20 to 80 degree at suitable temperature. The presence of cubic characteristic peaks are 220, 311, 400, 422, and 511 at 29.9 degree, 35.2 degree, 53.2 2 degree, 56.7 degree, 62.26 degree indicate the purity of sample. The crystallite size was calculated by using Debye-Scherrer formula and found to be 9 to 25 nanometer. The trend goes like, with the increase in concentration of rare earth metal, crystalline size decreases because of the significant strain and the decreased crystalline size. Verification was done by using William Hall's method, which gives the value of R, and the graphs are plotted against beta cos theta and 4 sin theta. Next, moving on to the humidity sensing behavior. Humidity sensing analysis was conducted using glass chambers filled with salt solutions and supervised by a humidity meter, rubber cork electrodes sealed with compartments. The sample in the form of pellets were connected to electrodes with the help of programmable digital multimeter to obtain resistance measurements. And the studies goes like, first the plot of resistance versus relative humidity with varying concentrations, and the maximum resistance shift and was achieved by the sample where with the concentration 0.15 cadmium rare earth, and it shows a sensing response of 99%, and the graph is plotted in this region.
Swati, please conclude.
Okay, ma'am. And the sensing response was recorded from 14.6 degree to 8.6 seconds, and 33% RH to 99% RH. And this shows the stability of nanoparticles. The conclusion, I conclude my topic by saying that the synthesized cadmium doped cobalt nanoparticles has an effective sensing response of 99% and can be used in various industrial applications. Thank you.
Thank you, Swati.
I have a question. Swati, I have a question. Can you go back to your experimental setup, sensing experimental setup?
Yes, sir.
Yes. This slide only. Next slide. Next slide.
Yes, sir.
Next.
Yes, sir.
Next one. Hi, this one. Humidity sensing behavior. So, can you explain this once again?
We took the salt solutions of different humidity, and we took the compound was taken in the form of pellets of different concentrations, and it was connected to the electrodes fitted into the glass bottle, and that was connected to a multimeter for the measurements of resistance.
Okay. But how much precise value you are getting with that multimeter?
Sorry, sir, I'm not audible.
How much precise values you are getting with that multimeter, I'm asking?
Sir, around we have took it was almost accurate values, sir, we got.
Okay. So this relative humidity, this x-axis is what is it? It's a time or what?
Sir, this is relative humidity percentage of RH, sir. Resistance versus relative humidity, sir.
Okay. Okay, thank you.
Yes, thank you, Swati. That was a good presentation. Moving forward, the next presenter is Sophia Sultana. Are you here?
Yes, ma'am.
Yeah, Sophia, you kindly share your screen.
One. Ma'am, can you able that HP, ma'am?
Yeah, you're audible?
Yes, ma'am.
Share your screen.
So that, ma'am, HP, can you enable, ma'am, that laptop?
HP, okay, yeah. Yeah, we are enabling. Enabled, you can share your screen.
Yes, ma'am.
Slide share mode.
Yes, ma'am.
Your time starts now.
It is enable, no, ma'am. Hello.
Yeah, you can start presentation. Your time starts now.
Good afternoon, everyone. My topic is lutetium doped zinc ferrites for humidity sensor application. Myself, Sophia Sultana Lakshmishwar. My outline of my talk is introduction, ferrite and its types, application of ferrites, synthesis method of ferrites, result and discussion. My motivation is the rarer dope ferrites are potentially useful for both low and high frequency application, including transformer cores, multi-layered chip inductors, information storage systems, ferrofluids applications, magnetocaloric refrigeration, and magnetic diagnostics. Introduction. The characteristic features such as high sensitivity, simple production, room temperature, operability, water absorption, compactness, and exceptional performance. The electrical and magnetical characteristics can be altered by doping and constructing rare earth dope Zn ferrites. The interest in Zn ferrites nanoparticles has recently increased as a result of their intergiving applications, which include corrosion, core of preparation, lack of need of complicated stools. Further, we have synthesized the Zn ferrite lutetium doped using chemical synthesis method by to study the structural, microstructural, infrared, and humidity sensors. Ferrites and its type ferrites are of two types, like mainly cubic and hexagonal. Further, it is classified into spinel and garnet. Application of ferrites. Ferrites are attracted due to their outstanding dielectric and magnetic properties in energy storage and a high frequency application. These ferrites also have a high resistivity, high saturation magnetization, and high initial permeability. Synthesis. Further, we have taken lutetium nitrate, iron nitrate, and zinc nitrate, which we have dissolved and glucose and urea in 1:1 ratio as a fuel, and further we have dissolved in 15 ml of water, distilled water, and it is kept for 450 degrees Celsius for 30 minutes in muffle furnace, which after that we have formed the powder of the nanocomposite. Later result and discussion, structural phase and phase analysis. The XRD patterns of zinc ferrite lutetium is represented in the figure 2. The XRD patterns were recorded from 2 theta ranging from 20 degrees Celsius at a suitable temperature. The presence of the cubic characters peaks at 220, 311, 222, 400, 422, like at 29 degrees Celsius, 35 degrees Celsius in the XRD diffraction patterns. All samples indicates that the prepared samples are pure and does not contain any kind of impurity. These peaks are confirmed good crystalline as well as cubic spinel structure. The average crystalline size were calculated by using Debye-Scherer formula and was found that the compound was pure and does not contain any impurity. This is the Debye-Scherer formula, where D is the crystalline size, and K is the Scherer constant, lambda is the wavelength, beta is the full width maximum in radius, theta is the Bragg's angle. Further, we have confirmed by Williams-Hall's method. The verification was done, and the results were confirmed by using the R value in the given below displayed graphs. These are the graphs of Williams-Hall's method, and it was confirmed and is verified as the pure compound. Next is the humidity sensing behavior. The humidity sensing is done to obtain resistance measurement upon being exposed to a specific relative humidity environment at room temperature. The further figure 3 illustrates that this is the figure 3 relative humidity and the resistance. This is showing that exhibits the more significant resistance shift and achieved a sensing performance of almost 97%. This is attributed to be more porous and active surface of the nanoparticles, which absorb water vapor and provide a site for the proton seeking, resulting in decrease.
Sophia, kindly conclude.
Yes, ma'am. In resistivity. This is the sensing response of Zn ferrite of lutetium dope. This is the nanocomposite, like it timing, recovery time, and the response time. This behavior was established because the composite has high porosity surface and large surface area. This is the hysteresis. The process of absorption of has been observed to be a little slower than the process of disorption. Later in the humidity stability, for a period of 2 months, the stability of zinc ferrite lutetium doped nanoparticles was assessed for every 10 days. For 11% and 97%, the sensing response was determined every 10 days, and the graph showing the relationship.
Conclude it.
Yes. Conclusion. This certain ferrite lutetium nanoparticle sensors is more effective and suitable for industrial application because of its epitome sensitivity, maximum change in the resistance, good response and recovery, minimal stresses and maximum stability. Thank you.
Madam, what is the response and recovery time of your stamp? Response and recovery time.
This one. Hello, sir.
How many seconds I have? Response is 6.5 work. I think recovery time is as compared to response time. It is suitable for device application or not?
Sir, it is showing like spontaneous. The outstanding quality is that short reaction and recovery time of the lutetium composite have been produced a good sensing response. Like in lutetium 0.05, we have found that like concentration 0.05, we have found that good sensing response we have found.
Sensitivity response tells the percentage or counts.
In the seconds, timing seconds.
That is in rest.
Okay, thank you, sir. The next presenter is the last presentation for the session is by Mr. Karthik. Sir, are you there? Karthik, sir, please share your screen.
Okay, if there is no speaker, let's finish it, ma'am.
Your time start now, sir.
Lakshmi, I am already
Mr. Karthik, you can start your presentation. So begin your presentation. What is the issue, sir?
Hello, good afternoon, ma'am. Am I audible for you?
Now you're audible, sir.
Yeah, okay. I'm sorry. Okay, fine.
You share your screen, sir.
Yeah, sure. So, good afternoon, everyone. My name is Karthik. I'm a research scholar from Reva University. The title is Exploring Multifunctionality of Polymer-Coated Rare Oxide in Optoelectronics, Latent Fingerprinting, and Anti-Counterfeiting Applications. So, I'm audible and visible for you. So, my PPTs are visible for you all.
Yes, sir. You can continue.
Yeah, okay. So these are the content I'll be covering now: the introduction, abstract, gaps, objectives, and what are the significant results achieved for me. So I'll explain you. So first of all, I prepared dysprosium oxide. So by using solution combustion synthesis, and then I coated the polymer, like it is a PVP polymer, polyvinyl pyrrolidine. So I used this polymer for the coating one. So the novelty of my work is I used coating method as like solution combustion synthesis. So later on I coated with the simple solution method. This is the novelty of my work. So I achieved some good results and all. So I confirmed. So my polymer is present and all by FTR later on, cement, all these things. The main thing is to avoid the agglomeration and to enhance the PL properties. So that is the reason I took polymer. So I took dysprosium oxide and all. So the main for applications are like latent fingerprinting, anti-counterfeiting, WLEDs. I'm focusing all these applications. So these are the gaps because to improve the luminescence efficiency of phosphor material, so using the solid state lighting and to achieve the high color rendering index and energy efficient. So these are many phosphor materials degrade at temperature and all these things. That is the issue. And the long-term reliability lifespan of phosphor material and all. Till now, there are a lot of materials are useful for LED application, but still there is a scope to improve the efficiency and life of it. So by coating DO2 like dysprosium oxide with polymer could enhance the luminescence property, leading to increased light output and improve the color quality. The polymer coating can provide the protective barrier, enhance the thermal stability of DO2O3 nanophosphorus. So we prepare DO2O3 nanophosphor, which is exhibiting a good luminescence property as a pure host matrix. In order to enhance the luminescence property, so I coated the polymer by a solution method to obtain DY2O3 polymer coated nanophosphor for optoelectronic latent fingerprinting and anti-counterfeiting applications. So these are objective synthesis and later on studying the structural, morphological and optical, and then comparative study of luminant fluorescent coated sample and to check to perform the PL studies, all these things. So these are the results. So you can see is the material is a crystalline material. So when I coated with a different mole percent, like 1 mole, 3 mole, 5 mole, 7 mole, weight percent I coated. So 9 mole was the optimized one. As you can see in the figure B, there is a slight variation because the thing is dysprosium oxide I prepared using the solution synthesis, solution combustion synthesis, and later on I took and then coated with the solution method. Then you can these things you can see a slightly variation in the so coming to the invisible spectra. So as you see, when coating the band gap is increasing because of polymer, and you can see FR present of DYO bond and polymer bond, all these things. So these are the same with the IDAC spectra. So this is the pure sample when I'm coating with different percentage, as you can. So these are the TEM results. This is a pure sample, and this is the coated sample. There is a grain on grain. So after coating, you can see there is a complete layer. So with the 20 nanometer, so this is a pure sample and is a coated sample. So as you can see, there is a complete coating layer. So I'll explain with the mechanism. So this is a polymer.
Mr. Karthik, you kindly conclude because your time is over.
Sure.
Yeah.
Thank you.
Complete your presentation.
Okay.
Okay, this ends the first session, first half of the conference. The next session will begin exactly at 2:10 p.m. So all of you are requested to join using the same link
At 2:15.
at 2:15.
Pause, sir. Recording pause ಮಾಡ್ತೀನಿ.
शायद
Hello.
Good afternoon, all. Welcome to the session 2. I would like to HOD, Electronics Department, KLE's PCW Science College, Hubballi, to introduce today's resource person. Over to you, sir.
Afternoon. It's my great privilege to introduce Dr. Gurumurthy Hegde. Currently, sir working as a director, Center for Advanced Research and Development, and professor of Material Science, Department of Chemistry, Christ University, Bangalore. Sir pursued his BSc in Physics from Pune College, Udupi in year 1997. Completed his MSc in Material Science from Bangalore University in year 2002 and completed his PhD in crystals from CSIR laboratory in the year 2007. Sir has a research corner of H index 32 and citations of 3,000 and 750 impact factor out of 200 journals, and Sir having 210 Scopus publications, and 40 conference proceedings, and 20 patents applied, and out of 20, 4 patents are granted. And Sir has a journal editor for 3 research journals and reviewer for 26 journals. Sir having researched 2.3 million US dollars, and Sir having received 66 awards, and they have signed 5 MOUs and one MOA and 3 NDA. And Sir also work in different capacities in teaching in India and abroad. And Sir received major awards. Some I have mentioned here. DST nomination grant winner in the year 2018, DST Early Career Award in year 2017, grant winner of DST nomination 2018. Sir C.V. Raman, Young Scientist from Government of Karnataka in the year 2017, Best Publication Award from DST, Government of Karnataka in the year 2017, Elsewhere Emerging Investigator Award in the year 2017, Outstanding Research in the year 2011, Best Invention in Asia Pacific Rim in the year 2014, DST Young Career Award in the year 2016, gold medals in USA, Japan, South Korea, Malaysia, etc. And under Sir's supervision, 6 students obtained PhD and 2 postdoctoral fellows, and 6 PhD students are working, and 6 master students finished their dissertation. And Sir has started one startup company. With this brief introduction, I conclude my introduction speech. Over to Naveen sir.
Thank you, sir. Now I would like to call Dr. Gurumurthy Hegade, Professor and Director, Center for Advanced Research and Development, Christ University, Bengaluru. Over to you, sir. Hello. Am I audible? Sir, you are not audible. Sir, am I audible? Sir, you is not audible, sir. No, sir. Still, it is not audible.
Volume full ಇದೆ sir.
ವಿಡಿಯೋ ಬರ್ತಾ ಇದೆ, ಆಡಿಯೋ ಬರ್ತಾ ಇದೆ ನಮಗೆ.
ಆಡಿಯೋ ಬರ್ತಾ ಇದೆಯಾ?
ಈಗ
It's clear now? Okay, sir. I will share the screen, sir.
Now it's audible.
Yeah, sure. So can you see the screen?
Yes, sir. Yes, sir.
Okay. Yeah. Sorry for those glitches. Good afternoon, everyone, and thank you, PC Jobin Science College, for inviting me to deliver the talk on porous nanocarbons from bio-waste development criteria. So for the next 55 minutes, I'm going to explain about how we developed this bio-waste material and how we converted them into nanocarbons and how we made the how we brought porosity into it. And then what are the major bio-waste, because we did more than 50 bio-waste material we scanned so far. But today's talk, I will only talk about 3 major bio-waste where we got very high results in terms of porosity, in terms of surface area, in terms of application. So I'm mainly concentrating on those 2 bio-waste, and then I will summarize how to go forward in these kind of bio-waste materials. So when I said that innovations is a part and parcel of research, without innovation, we can't go anywhere in the research, because it's not just about publishing the paper, it's about how impactful research we are doing, because number of papers are just the number if it is not converted into a commercial line. If our product one day come to the society, that means that our research is on the correct line. So that's why innovations is very important. When I said innovation, you can see this picture. If I ask you this picture, you only can see one old lady, but if you concentrate, focus, and think more about this picture, you can see that one old lady is here and one young lady is there. If I remove this now, you can find out there are 2 ladies are here. One is you can see here, this is the face of the young lady and this is the face of the old lady. So innovation is a combination of experienced people, that means old people, that they are more experienced, and the young people. So innovation always connected with this young and old mindset. Whenever this experience and the young mindset will club together, we can do wonder in research. So having said that, I will give a very small introduction about our center. It is a center for advanced research and development situated at the Dairy Circle, Christ University Central Campus. You can see here, if you put a line between, the center is working on two main aspects. The one of the aspect is we are working on nanomaterials from bio-waste. That's what I'm going to talk about today. On the other hand, we're also working on liquid crystal material, where we are synthesizing the liquid crystal. We are using those kind of liquid crystal for the liquid crystal displays, and also we are using for photonic application, where we are shining the light to the material. Then we are seeing how the molecules oriented with respect to the light. So these are the major equipment present at the center as at the university as well. Central instrumentation facility mainly caters to high resolution FESCM with EDAX, which is a very top end model we purchased. We have a Raman and we have XRD. It is not only for the Christ University students, but it's also catered to the outsiders as well. So anybody can approach us, and with nominal price, we are giving these characterized to the outsiders. And inside the department, whether physics, chemistry, biology department, we are having all these and other kinds of equipments. And also, we also have class 1000 clean room, which is not completely ready. I think within another 1 month, it will be ready. So whenever we are doing research, the funding is very important. Unfortunately, India is just growing now. It's not like United States, Japan, and China, Germany, where they are investing several $100 billion for the R&D development. But India, you can see here, India is still investing only $48 billion. Compared to our population, this is really very less. So that means there is a lot of scope on research and development, because the Prime Minister already told that they are going to invest a lot of money. That's why National Research Foundation came, where through National Research Foundation, they want to invest huge amount of money for the societal oriented research. That means impactful research need to be developed in this country, and product need to be come to the market. So in these kind of research thing, you can see that how technology is developed, why innovation is very important. If you see that in 1980s, if you are sitting on in front of your table, you don't have any space to write your notes. Because as the laptop discovered in 1990s or 1985 and so, you can see that all your gadgets, whether you take a telephone, whether you take a fax machine, newspaper, dictionary, your books, your photos, everything went inside the laptop. So now you have plenty of space to write your notes or anything. In other words, in 1980s, if you want to carry all these gadgets, which you are seeing today, you can see all the gadgets named here. It is estimated that you have to carry 250 kilograms of luggage with you. And today, your 250 grams of mobile is carrying your 250 kilograms of luggage. That is a phenomenal technological orientation, digital transformation took place, where within very short span of 35 years, we never imagined that the mobile which you are carrying, having some 250 to 500 grams of mobile, is carrying 250 kilograms of luggage. So that's the power of innovation. That's the power of technology. So whenever the material becomes smaller and smaller, you can able to get the wonder results in everything. So which area we have to concentrate more in the next 50 years? This is a World Health Organization has released this, where they told that next 50 years, these are the main areas which all have to concentrate. The first main area is the energy, because energy, as population increases, demand for the energy is increasing, but the supply for the energy is decreasing. So we have to concentrate energy, which is extremely important. And the next is the water, which is again one of the very important aspects you have to tackle, because again it connects to the population. Food, environment, poverty, terrorism, disease, education, democracy, and last important problem to tackle for the next 50 years is population. So the population is not at all a main problem we have to tackle. First, we have to tackle on energy. If any of our research is concentrated on these 10 points, that means we are on the right track for the next 50 years. This is according to the World Health Organization. I hope that. Okay, next slide is not moving. Okay, so then question is why nanotechnology is very important. So now you can see that in medical field, already 30% of the medical devices is made up of nanotechnology. And in the energy sector, already 30% of the energy sector using nanotechnology, and agriculture is just growing now. Agriculture is just 10% agriculture is growing, and display is already 20% and others is 10%. Every branch of science and technology is using nanotechnology in various applications. So today, there's a lot of nanoparticles around. You can see gold nanoparticle, silver nanoparticle, and metal nanoparticle, everything. But my main concentration today is on carbon allotrope because that is the low-cost material. Not everything, but whatever I'm talking today is the low-cost carbon nanoparticle. When it is the porous in nature, it can do wonders. So carbon allotropes, you can see we have a zero-dimensional carbon, which is about spherical in shape. We have one-dimensional where spherical shape has been elongated, which is like a multi-walled carbon nanotube, single-walled carbon nanotube, where toxicity level is also as you increase the material. Then we are also having two-dimensional, like a graphene layers, and we are also having a three-dimensional where you can consider about diamond. So all these materials are extremely important and it is abundantly available. So we are concentrating on zero-dimensional, which is especially for the carbon nanospheres. So as you all know that how to synthesize such kind of carbon nanomaterial, mainly two approach. One is the top-down. You start with the bulk material, end up with the nanoscale. So another is that atomic scale you start, you end up with the nanoscale. So what are the technique in bulk to nano? You can do the ball milling, laser ablation. Whereas in atomic scale to nano, you can do the CVD, salt gel, hydrothermal, all these things. If you want to more details, you go to this chapter. It's very nicely explained by Kumarita. So what is the things can be done for the nanotechnology, but what kind of application you can think of when you have such kind of nanoparticle? So this is the very beautiful slide. You can see if you put your nanoparticle here, then you can see all the first line application like textile, biomedical, healthcare, food, agriculture, industrial, electronic, environment, and renewable energy. If I put a line here, for example, in biomedical, if I put a line in across here, you can see that second line application is drug control, release, cancer therapy, drug delivery, imaging, antibacterial. Third line is MRI, contrast images, hypothermic treatment, biomarkers, molecular tagging, bone growth, dental ceramics, so on and so forth. Whatever application you want to tackle with respect to these 8 areas, everything is included here. So that's the power of nanotechnology. When material becomes nano in structure, it is, you can tune them with respect to electric field, optical field, magnetic field, so on and so forth. Whatever the field you are talking about, the value of those things will 10-fold increases because of the higher surface area in them. So this I already told you. So what happens when nanoparticle based devices comes to the market? When nanoparticle comes to the market, think that 90% of your all devices made up of nanoparticle, then factories will be minuscule. You don't need to think about huge 100 floors company. You need a very small factories to do that. Customization is not much because you are targeting about nanoscale. Simple repair techniques, you don't need to worry about that. Whole sets of big industries will be eliminated. Already remote control devices is there. They are using the nanotechnology in that. Affordability will be easy and cost will be easily affordable. So what lesson learned from last 10 years in this kind of bio-waste material? We scanned more than 50 bio-waste material here. One of the biggest lessons we learned is the selection of bio-waste. It's not that whenever you read the literature, you see that bio-waste material is easy to do because you can take waste material, make a nanoparticle, do some application, publish the paper. You can publish the paper. I'm not telling that you cannot publish the paper, but problem is you cannot make the devices which is acceptable to the industry standard. So selection of the bio-waste plays a very dominant role in these kind of areas. So you should know which bio-waste you have to target, why you have to target that bio-waste, and what are the advantages of these bio-waste, and how to convert them into a porous nanoparticle. And also you should know about how to tune the mesoporous structure in that. That's a very important thing in this kind of bio-waste material. The second important thing is a size reduction. What kind of size you are looking at, whether you want 40 nanometer, whether you have 100 nanometer, that need to be tuned. Gas flow, because you are doing all this experiment in the inert gas, you should know that how to control the gases, whether it is nitrogen or argon, and time control, how to control the time during the gas flow, and adsorption. You have to make sure that your nanoparticle is having high adsorption, high surface area, and high porosity. Especially we are talking about mesoporous range between 2 to 10 nanometer in diameter. Pyrolysis temperature is very important part, and most importantly, the crystallinity. Most of the nanoparticle which you synthesize, you end up with either turbocrystalline or it is non-crystalline in nature. So you have to make sure that whatever bio-waste you are taking there, where you are converting them into a nanoparticle, you should get the crystalline nanoparticle. Then only you can able to use them for high-end application. The next question is why bio-waste is required. You can see that there's a lot of household waste, lot of bio-waste I listed here. Why bio-waste is required? Because bio-waste is the only thing available abundantly with very low cost. Whereas if you take any other kind of material where precursor, you have to spend a lot of money. But here precursor is easily available and society don't want that precursor to be kept in the society. Someone is going to give you and you have to take it. So that's why it's a very cost-effective technology, because precursor, you don't need to invest money on that. So then question is why, what is the advantages of using bio-waste material? So if you see normal trees, if you take, normal trees contains the cellulose. And you all know that cellulose contains the silicon, and silicon is nothing but a porous in structure. Entire nature is having porous structure. So we have to take that porous structure and convert that porous structure into a carbon-based porous structure. That's the whole story behind synthesizing the bio-waste-based nanoparticle. Because usually whenever you are synthesizing nanoparticle, people will dope external agent to get the porous material. But here is nature is so beautiful. Nature already put the porosity in it. So only thing is we have to tune that and we have to make our nanoparticle becomes porous. So why porous nanomaterials is very important. We don't want micropores, only very near to micropores we are interested, but mainly majority of the nanoparticle with having diameter between 2 to 50 nanometer is extremely important for this study, because they are the one who's giving the very good porous values. They can be used for various applications, but macropores again not useful. So what happens if you synthesize such kind of mesoporous nanoparticle? Undoubtedly you are getting very large surface area if you have very good mesoporous material. High specific capacitance because it is directly connected with your surface area. Once surface area increases, high specific capacitance also increases. Better absorption, CO2 absorption, where you can tackle to the global form problem. High porosity inbit, which I already told you. Most importantly, you can synthesize such kind of mesoporous material in tons of scale. You don't need to worry about whether you can take it to the market or not. You can easily, from yourself only, you can synthesize in tons with a very uniform shape. And most importantly, it's a cost effective because you are taking the waste material from the environment. So how to synthesize that? Take any bio-waste material, sieve it to a particular sizes, subject it to a tube furnace where your sample is sitting here. You can see the sample chamber. Heat this, close this furnace and heat it to the elevated temperature, and you will get very beautiful carbon nanoparticles. You can see here. So efficiency, selectivity, sensitivity, cost effectiveness, and environmental friendly are the highlight and the feature of such kind of nanoparticle from the bio-waste material. The next question is what temperature you have to synthesize. Take this precursor, subject it to thermal gravimetric analysis. Whenever you subject it to thermal gravimetric analysis, you can see that weight loss taking place. Initially, it is 100% weight loss taking place. You can see here. And at 600 degree, almost 90-95% is converted. So that means even if you synthesize nanoparticle in this region, that means your nanoparticle is completely a carbon and porous in structure. You are not sure whether it is porous or not, but TGA suggests that this is the safe temperature to synthesize the nanoparticle. The next you have to do the oil palm. This is the one waste material we tried. OPL means oil palm leaves we started with. Next, you have to do the FTIR. Whenever you do FTIR, you can see that you are having SiH, SiCH, all silicon peaks are present at respective bands. That again tells that the bio-waste material contains silica in it, silicon structure in it. Then you subject it to XRD. XRD again says that there is a silicon peak present here. And again, you can see 11002024 planes, which is corresponding to the silicon. Then next is FESM index. As you know, whenever you take any bio-waste material, there's a lot of elements present because it's a natural one. It is not at all treated with anything. You can see carbon is 49%, oxygen, sodium, magnesium, aluminum, silicon, potassium, and calcium. You can see Si1. This is very important. Any bio-waste material you take, your silicon percentage is less than 1%. This is the one special kind of bio-waste material, oil palm leaves, where the silicon percentage is more than 10%. Why it is more than 10%? Because this is the material is having very rich lignocellulosic content. So why it is very important, I will explain to you in the next. Okay, if you want to more detail, you can go to our paper in Chem Communication, where we published in 2014. And this very surprising thing is now we have synthesized the nanoparticle at different temperature. You can see very indifferent structure. XRD is like this. Here, XRD is completely crystalline. As I already told, any bio-waste material you take, you never get crystalline peaks. It's not easy to get the crystalline peak. But in this special bio-waste material, it's not only crystalline peak, but with respect to temperature, there is a multiple peak present, which says that you are going towards graphitic region, which is again very important for the application point of view. If you go to the FTIR, now there is no silicon peak. Most of the FTIR peak are corresponding to the graphene material like C double bond C. You can see all C double bond C with respect to the temperature it is coming. So that again tells that you are going towards the graphitic nature in these kind of nanomaterial. When you subject it to the Raman, you can see that all the Raman characteristic peak like D band, G band, G prime band is present at the same position where it is expected to be. Then we did the FESEM. You can see FESEM of different temperature. I just zoomed this portion. You can see all these three spherical particle size is almost the same, highly identical. That again says that this material is spherical in shape. Still, we don't know whether it is porous or not, but it says that it is spherical in shape and average particle size ranging between 10 to 40 nanometer, which is acceptable range for many applications. And this is the carbon percentage, but at 700 degree, we got 44%. Actually, we are expecting 90% here. We are still working on these things because there is some magnetic particle induced at 700 degree, which is still confidential data. I cannot put it in this one. Then we did the transmission electron microscope, where transmission electron microscope, you can see that it says that it is not only spherical, it is also porous layers. You can see the porous layers here. All these porous, like a graphitic layers, you can see these porous layers. So we have nanoparticle with spherical shape and also it's a porous in structure. So next we thought, what is the stability of these nanoparticles? We synthesized nanoparticle from 400, 600, 800 and 1000 degree. As I already told, TGS suggests that only after 600 degree, your nanoparticle starts taking the spherical shape. You can see in 400 degree, there is still weight loss is there. 600 is a very small weight loss. But 800,000, you can see from room temperature until 1000 degree, they are very stable. That means that such kind of nanoparticle is very stable throughout the temperature region. So you can use it for various applications. And if you do the ID by IG ratio, again, as you increase the temperature, you are getting around more than 1% by ID by IG ratio. Then again, if you subject it to XPS, you are getting the carbon and oxygen at the characteristic positions, which again says that material is highly confident, highly competitive enough to take it to the market. So then we measure the BET surface area, which is very vital information whenever you're talking about nanoparticle. So now you can see that the surface area of this kind of nanoparticle is only 126 meters square gram. So all experiment we did, we measured everything. Finally, we came to know that the surface area of this nanoparticle is extremely low, which is very disappointment for us because we thought that all others are good, surface area might be good. So now slightly we move to the other kind of nanoparticle. I will explain about onion later in the application part, OPL. Now we move to the onion. Why onion is? Onion is known for various health benefits. Here you can see I already listed all these things. Adding to that, India is one of the biggest exporters of onion to the entire world, especially the west part of India and the south part of India. They are biggest exporter of onion. So now Prime Minister told that whoever working on onion for the last 1 year, they started the scheme called Onion Grand Challenge. So whoever working on the onion, the government is ready to fund for that. So we got the funding from this Ministry of Consumer Affairs about Onion Grand Challenge, where we are working on how to use onion peels for making nanoparticles. So this is how we started. We took the onion peels, we grinded it to a different size, then we get the nanoparticle. So advantages of this one here, you can see when you start synthesizing onion at 200 degree, you won't get the spherical shape. But as you increase the temperature around 700 degree onwards, you can see that perfect spherical shape is forming. That means that the temperature plays a dominant role in synthesizing the nanoparticles. So this is the zoomed view of these FESEM images. You can see 200, 300, 400, 500 small spherical shapes starts forming, 600 better, 700 even better. You can see 800, 900, 1000. You will get very beautiful spherical shaped onion porous nanoparticles you got. Same thing goes to the TEM. TEM also suggests that as temperature increases, your porous nature also increases. You can see the very good porous particles is observed, and also it's spherical in structure. So then we measure the XRD analysis of all these temperatures. As usual, I already told 200, 300, 400 nanoparticle is not at all formed. Still, it is lignocellulose content, and you are getting various kinds of. But as nanoparticle starts forming, you can see 500, 600, 700, 800, 900,000. As nanoparticles forming, you are getting very good crystalline peak, even in the onion also. So that again tells that they are crystalline in nature. Then we did the Raman. Raman again showed the same thing, 200, 300, 400, we couldn't able to get any data. Whereas 500 to 1000 onwards, you can see that D and G band is coming at the characteristic places. The next important part is the surface area, because if our surface area is low, again, we have to discard this material. So we measured the surface area. This you can see very perfect adsorption and desorption curve. And also pore diameter is acceptable from 2 to 50 nanometer range. That again tells that they are mesoporous in structure. So now our surface area is 2,961 meters per gram. We started from 126 gram with our previous bio-waste material. Now we got 2,900, which is highest reported bio-waste material in the entire world. So this is extremely good, because nobody wants such kind of surface area for application. Even anything below, anything above 800 degrees sufficient, but this got almost 4 times higher than what we expected for these kind of materials. So these are the summary of the onion nanoparticle. We started with 200 to 1000. You can see initial carbon percentage is 58%, and all these kind of materials present. As we increase the temperature, you can see that one by one got eliminated. And at ON10, we have 90% of carbon, 8% of oxygen, and 0.6% of potassium. So if we design very well with the help of engineers, we can able to reduce this oxygen, because small leakage is always there in the tube furnace. Because of that, oxygen will enter. But if we design this very well, you can able to get 100%. If we get 100% of carbon, surface area will also reaches around 4,000. That's what we are doing now, and we are trying to increase the surface area. But when with respect to the particle sizes, if you synthesize carbon nanoparticle at 500 using onion, you have a particle size about 150 nanometer. But same onion peel, if you synthesize at 1000 degree, you will have 63 nanometer. Same thing, surface area, if you want 200 meter square per gram, you have to synthesize here. If you want 2900, you have to synthesize at 1000 degree. And same goes to the pore diameter, they are in the mesoporous nature. So that means one nanoparticle is having different solutions. If you want to use it for water purification, you need one surface area. If you want to use it for sensors, another surface area, supercapacitors, another surface area. It's all depending on what kind of application you are targeting by using such kind of porous nanoparticle. The next question is how you are getting the porous structure. Why do you confirm that porosity is added into that? Because I told that silica template is there. So whenever you have such kind of nanoparticle where silica percentage is extremely high, silica is porous in structure. So silica create the porous template for the carbon to come and sit on top of it. The next question is whether this kind of argument holds good for all the bio-waste material. The answer is no. Because we again scanned another kind of bio-waste material from the sago hampas, which is not having high lignocellulose content, and silica content is less than 1%. For our surprise, whenever you use such kind of low quality, low percentage of silicon, it is not the template created by the silica, but it's because of the glycosidic linkage present in them make the porous structure. So what's the advantages of these two methods? Whenever you have these kind of thing, the zeta potential, that means absorption values are extremely low compared to these kind of material. Whenever you have the glycosidic linkage based nanoparticle, where your absorption zeta potential value is minus 30 and above, minus 30 millivolt and above, here minus 25 to minus 27. So both nanoparticle is advantageous with respect to different application. When you have high zeta values, you can use it for biomedical application where zeta potential plays a dominant role. If you don't have high zeta potential value, you can use it for water purifier, you can use it for energy storage devices, nanocomposite material kind of applications. The next we move to the other kind of bio-waste material, which is called as a areca nut, areca catechu, because we all know about areca because You can see here statistics of Karnataka and Kerala. The production in 100,000 tons. The Karnataka is producing 457,000 tons of areca nut every year. Okay? And areca nut area is 218,000 hectares. It's not a small area. And Karnataka and Kerala is contributing around 60 to 65% of the total areca production in India. But unfortunately, this areca nut is used for the gutka production. So government continuously trying to utilize areca nut for the societal application other than the gutka. So why areca nut is very important? You can see this areca nut structure. It is having pyridine and pipyridine structure, which is very important when you heat the material to elevated temperature. Apart from this, you can see polysaccharides is around 60%, lipid is around 15%, and tannin, which is 15%, which is extremely important in areca nut. Whatever the taste you are getting in areca nut is because of the tannin, polyphenols present in them. So not many bio-waste material is having this polyphenol property. So we thought that why can't we try this areca nut, because polyphenol percentage is very high. We did the TGA. Again, the TGA is very encouraging because all the bio-waste material we scan, TGA starts from 600 degree, but you can see here, even 400 degree itself is almost 85% weight loss is taking place. That means it's a highly competitive material, because even from 400 only spherical shape starts forming in this kind of material. And adding to that, I already told areca nut produces around 6 million, only in Karnataka, 6 million farmers are depending on areca nut. And areca nut is not a native crop. It came from Malaysia. 2000 years back, it came from Malaysia. And from that, it is a part and parcel of our culture. What the factors influencing this areca nut market? One is the weather condition, because sometimes areca nut price is very high, but areca nut crop is less. Sometimes crop is very high, price is less. Government policies over the pricing of betel nut is always changing. Carry over stocks, because you can carry this areca nut for 5-10 years without any problem, so that the big vendors will keep this areca nut and they will dictate the market whether to increase or whether to decrease. And growth of the consumer industries, because so many people are nowadays they're removing the paddy fields and they're putting areca nut into that. And the day will come where entire Karnataka is filled with areca nut. So what to do with that? Government policies over the consumer industries again will not encouraging for the areca nut farmers. So now it's a time to use areca nut for the societal application. What are the application advantages here? It has been used for anthelmintic, nervine tonic, and vermifuge for the dogs. And also disadvantages is nowadays people are telling chewing areca nut is a toxic and it produces the oral cancer, and reproductive issues are also there. There is no strong evidence on these things, but this is how the Cancer Society of India has put a case against the areca nut farmers in India. So what are the application of areca nut is presently available? One is the areca tea, which you might have tasted, which has been done by the Shimoga person. And apart from that, areca bags are there, areca plates are there, all these applications are there. So is it possible to use areca nut for the high-end application like pharmacy, defense, energy, water, health, automobile, aerospace, and sensors? That was the main idea behind the synthesis. So what in our laboratory, what we did is we make this areca nut nanoparticle with very high quality, and then we use this areca nut for the unbreakable glasses. We use areca nut nanoparticle for the road construction in civil engineering, where we are, where I will explain the latest slide. Pharma industries as a catalyst, low-cost batteries we prepared, low-cost sensors, then low-cost water purification we did. Electronic vehicles we are using now, effective water filtration membrane, low-cost display technology, low-cost lighting boards, highly durable bathroom fittings, and still applications are counting. We try to make this as much as possible so that we can make everything from the Make in India concept. So we don't need to depend on foreigners or foreign vendors for anything. Everything we have to create from the available resources in India. When I'm telling about resources, it's not about how many resources you have. It's about how you use your resources. If we don't know how to use our resources, it will be like this. This person is having a lot of ladders, but he don't know how to use the ladders effectively. That's what, whenever we are having some good result, we have to be very clear about how to use these good resources so that we can bring to the market. Then again, when areca nut, different kinds of particle and temperature, if you use, you can see the different kinds of particle sizes. You can see if you synthesize at 700, it's around 90 nanometer. If you synthesize at 1000 degree, you can say that 50 nanometer. So again, these kind of arecanut, just arecanut contains the arecaidin, arecolin, guanine, isoguanine, tannin, then lignin, all contains OH groups. So when you synthesize nanoparticle, you won't get OH group, you will get carbon. So there is a high possibility that you can functionalize these kind of OH groups and you can use it for different kinds of application. The next question is, we synthesized the arecanut nanoparticle. I already told in the earlier cases that our maximum carbon percentage with onion we got is around 90%, right? So now you can see how much we got here. This is the 700 degree itself, we got more than 96%. As you increase the temperature at 1000 degree, we got around 40 nanometer. You can see here. This one, my next slide is showing the carbon particle size. But this, you can see the weight here. In the raw sample, you have 75% carbon. This is where the very arecanut plays a dominant role. Any bio-waste material you take, the raw sample, your carbon percentage is around 50 to 55. And during pyrolysis, it adds another 25. So you will end up with 85 to 90. But here, carbon percentage itself is 75. As it is, arecanut is rich with carbon. So if you synthesize, you can get 98% of the carbon. You can see at 1000 degree, you have only 98% of carbon and 1% of potassium. So highly purest form of carbon you are getting in the entire world based on these kind of bio-based material. So that is very important. When your carbon percentage is very high, you can use it for various applications. But the next question is whether it is sufficient to synthesize at 700 or you have to go to 1000, because if you ask the industrialist, he will tell that 700 is sufficient because he can save 300 degree time, money, everything. But if you synthesize at 700 degree, your nanoparticle size is 100 nanometer. But if you are looking for nanoparticle sizes to be 40 nanometer, then you have to synthesize here. It depends on what kind of application you are looking at. If you are looking at the application around 90 nanometer, then 700 degree synthesis is enough. So now you can see the FESM images and TEM images. You can see very perfect spherical and porous structure. This is TEM, this is FESM. Very beautiful spherical shaped images is formed in these kind of nanoparticles. Then again, FTIR, you can see FTIR images. It is CH bending and glycosidic linkage is present here. And whenever you synthesize this one, your FTIR shows the C double bond C like a graphene materials. This one. Then we measure the BET surface area. So you can see at different temperature, when you measure the surface area at 1000 degree, we got around 884 meter square per gram as surface area. And pore diameter is, you can see they are not only mesoporous, they are also going to the microporous structure as well. This is the unique property of arecanut. In both regions, they are equally holds good. So these are the application we tested. So these are the success stories on this direction, because when we synthesized this arecanut and made different kinds of application, there's a lot of Karnataka news channels and the TV channels invited me to explain about this technology. And because Karnataka government, previous Karnataka government is interested to work on these things, because they are mostly interested about how to this one. Now we are again working with the more applications so that we can take it to the market. So next another 10-15 minutes, I will explain about what are the application we tried using such kind of material. This is the first application where we are working on defense related sector, where we made the nano composite material, where the bio-waste material has been reinforced with the nano composite. So the advantages of, you can see all the procedure we put, how we have to do all these things. Then whenever you make this kind of thing, you have to measure the tensile strength present in them. You can see it is the neat epoxy. The blue color one is the neat epoxy, and this one is a blue color one is the 0.1% doping. Red color one is the 0.25% doping of the nanoparticle. So whenever you have doped, you can see even at 0.1% already increased and 0.2% drastically increased in stress and strain curve. That again, we summarized here. Your ultimate strength in neat epoxy and 0.1%, 0.25. There is almost 15 to 20% increase in all the parameters. That again tells that these kind of materials are highly durable for various display or various space related application, where the strength, lightweight, and affordability and durability, everything matters a lot. The next we move to the electrochemical determination of nitrite present in seawater, lake water and all, where we published the paper in Journal of the Electrochemical Society, where we told that if you use areca nut based nanoparticle for these kind of determination of nitrite, you can able to get, you can see here, the high sensitivity, low level high sensitivity is around 28.9 milliamp per micrometer, this one per centimeter square. So that again tells that this kind of nanoparticle is extremely important for the sensor related application. So next we tried one more thing for the pharmacy industries. You can see here, what we did is we used a nanoparticle for Suzuki-Mehra coupling and nitro-arin reduction. What we did is, instead of palladium carbon, we replaced with palladium carbon nanosphere. So whenever you put carbon nanospheres along with the palladium, the dosage of palladium is 70 to 80% reduced. That means even the 10% reduction of the palladium will save millions of dollars to the pharmacy industries. And here almost 70 to 80% reduction of palladium, and all remaining property will be given by the CNS. So excellent result we got in this sector, which is ready to be commercialized. Then we also tried carbon nanoparticle based areca nut for the water purification along with the Japanese group. Then this is how the catalysis, and also we worked on kitchen waste derived mesoporous nanoparticle, especially onion nanoparticle for this kind of metal free degradation, so that you can degrade the azodite easily. And when it is degraded, you will get the starting material, and you can again reuse this nanoparticle, use this azodite for different applications, so that your azodite is not going for waste, it is degrade, and there is no metal is required, because already industry is using metal based degradation, but here it is completely metal free degradation. Once it is degraded, you can use it for some other kinds of application. This I already told you. So now again we moved with respect to the Malaysian group. We worked on nano in health sector, where we are working on cell imaging and targeted drug delivery, where such kind of high absorption based nanoparticle can be used for targeted drug delivery. So we have tested on a couple of cancer cells like osteoblast cells, and we measured the phase contrast images, and it tells that this nanoparticle is having very compatibility with bio-based materials. So now again we worked with display related area, where we mixed nanoparticle in liquid crystal displays. So because all the liquid crystal display industry is looking for increased birefringence properties for liquid crystals, but only with liquid crystal you won't get increase in birefringence. But whenever you dope small percentage of nanoparticle to such kind of system, you can able to increase the birefringence effectively. That's again advantages for the display industries. Then this is already told in the water application. And this is the one which we are trying with the Tamil Nadu University, where we are working on nano in construction industries, where we are taking 53 grade cement and 63 grade cement, and we are mixing nanoparticle to 53 grade cement, and we are measuring both 63 and 53 grade cement. Our idea is to make 53 grade cement as 63 grade cement by doping the nanoparticle, which not only helping the construction people to construct the same house with better cost and lower cost, but also get the same strength like 63 grade cement. Then nano is roses. It's the most fundamental kind of thing, where we gave our nanoparticle to Italian group, Paola Padova group, and they studied the nanoparticle, and they told that whenever such kind of nanoparticle is present, it's also having copper nano roses inside, which is very deep. You have to go. You need very sophisticated TEM machine or FESM machine to understand this kind of thing. Whenever you have copper nano roses present in such kind of nanostructures, you can use it for gas sensing application. Then nano is also used in photomechanical actuators, where you can put nanoparticle along with gold and PDMS, polymer dispersed material. And when you use this, you can able to tune the actuators systematically. Then nano in also used as along with the CSIR SICRI group, we are working on electrochemical tracing. So where tracing of butene is very important part of research, because that's where many people are working on this kind of direction. The tracing of butene is possible along with these kind of nanoparticles. Again, with SICRI, we worked on oxygen reduction reaction using nanoparticle, especially garlic peel-based nanoparticle. As I already told, different nanoparticle is having different application. Don't think that one nanoparticle can be used for all the other application. The oxygen reduction reaction is very important, and this kind of material can be an excellent candidate for oxygen reduction reactions. So nano in CO2 reduction, which is the collaboration with Australian group like Ajay and Vinu group, and also with the Jain University Mahavir Kurkuri group, where we are working on the how to reduce these, how to absorb the CO2 using these kind of nanoparticles. The next future in automobile industry, because you already know all automobile industry is working on carbon nanotubes. So our main aim is to replace this carbon nanotube, which is very expensive. And we want to replace this carbon nanotube with our carbon nanospheres so that it not only save the time and cost, but it's also very lightweight, and the strength is extremely high in comparison with the already available material. So nano as a supercapacitor is one of our prime area where we got a lot of grants also. So this is the one application I did. We connected the LED wire, LED bulb to this cell. This is the cell we prepared in the lab. And when you charged the cell, we connected this LED, almost 20 minutes, the LED could able to grow with the same intensity. And we measured before and after, even after 5,000 cycle also, there's not much area reduction taking place, which again implies that these kind of materials are excellent for energy storage capacitors. So this is for the aerospace industry. We made a couple of devices like this. We made a pipes made up of nanoparticle. We made such kind of designs. We made a these kind of bendable thing where advantages is even if you can drill a hole, you can see that there is no cracks generated. If you don't put nanoparticle, if you just use the epoxy, cracks will be generated. So these are the various items we did. So in a nutshell, it is one of the rich dividend crop bio-waste based research, because so many things are toxic to non-toxic approach is required for the industry now, because now everybody is moving towards sustainable development goals, SDG goals. So it's highly following the SDG goals. You are working on green chemistry and green techniques, diversified application. That is another advantages of bio-waste material. But only thing is the increasing the surface area is a real challenge in these kind of material. If your surface area is low, it's very difficult to work for the different application. And whenever you have such kind of material, obviously it will strengthen the economy because you can use such kind of material for different application. So where we can work together in these kind of research collaboration is very important. I put principles of collaboration where we have to keep our confidential thing. We should not steal others' idea to our work, but in the same time, we respect others' idea, and also we have to work together as a team. With respect to that, I am happy if any one of you are interested in to work with us in these kind of areas, because we are constantly looking for new application. If any one of you are working for some different application other than what I presented here, I'm really happy to start that kind of collaboration, because that's what we are looking for, different application for the nanoparticle based research in bio-waste material. So after all, we have to save the Mother Earth. If the Charles Darwin theory really holds good, when man was monkey, you can see other is Earth is like this. When monkey becomes man, Earth is like this. So in the name of technology, in the name of digitalization, in the name of achieving something, we should not destroy our Mother Earth. So this is our future. This is what one of the Google says. If we work like this, because we are continuously using mobile phones, if human evolution is really true, then small brain for the future kids, where small brain as thinking will be done by Google, eyes set downwards to look directly into the phone, special long thumbs to facilitate scrolling on Android, small legs, because nowadays everything we are ordering online, we are not using our leg. If any parts not used for continuously, it's going to diminish in a coming term. That's how the Darwin's theory says. With this, I thank my team because they are my strength. Whatever I presented today, it's all because of these fellows. They are working in the lab continuously, and they are the one who is giving good results to me. They are here in this group. We are having PhD students, we are having postdocs, and we are having master's internships. They are working continuously for giving the ideas which I'm presented here. I thank the PC Javin Science College, also Dr. Jagdish, for inviting me for this talk. And also my special thanks to my funding agencies, because it's not easy to do the research without the sufficient funding. We have a good funding support from VGST, Government of Karnataka, Department of Science and Technology, SERB, and Christ University, and also my startup company, Adindistech Private Limited. Thank you very much. Any questions?
Thank you, sir, for enlightening us about green approach regarding use of bio-waste as nanomaterials in various ways. Any questions from audience side?
Yes, ma'am. Can I?
Yes, I can ask.
Sir, there is a question from audience.
Sir,
can we compose inorganic? Hello, sir. May I audible?
Yeah, I cannot hear you. I cannot hear you. Yeah, you can ask the question.
So there is a question from audience. Can we composite inorganic materials with green synthesized carbon nanomaterials?
Yeah, you can try. There is a couple of methods you can try for inorganic materials with green synthesis. I don't know about the toxicity part of this, because that is where SDG, Sustainable Development Goals, come to the picture. Because nowadays many industries are looking for green approach with low cost. I don't know whether your inorganic material is a cost-effective approach or not. Maybe it might be only for fundamental interest, or it is for the application that you have to think. But definitely, combination of couple of things you can able to synthesize.
Thank you, sir. Any questions from other audience?
Yes, ma'am. Can I ask?
Yes.
Hello.
Yes. Thank you, sir. Yes.
Yeah, you can also note down my email ID also. If you have any question, the latest stage, write to me.
Yes,
WhatsApp.
sir, I am a PhD.
Sir, please, Mona.
Hello.
Yes. Yeah,
yes,
tell me.
Yeah, sir, I am a PhD student pursuing my PhD in this area of research only. The question always arises me is that how we can mass produce these nanoparticles, because whenever we try to synthesize them in our lab, the yield is very low. It is in grams only. But if we want to move in industrial area,
no, yield is low means how much yield you got?
What are the approaches? Sir, it is in grams only, like 10 grams.
No, grams means in terms of percentage. For example, how much you put and how much you got.
Yes, sir. In the react, near about 60 to 70%, depend.
No, usually any of these kind of such kind of bio-waste material. See, any of the bio-waste material, the yield is easily.
No, sir, we haven't. But we are planning to.
Okay, so yield of that kind of this one, usually you will get around 30 to 35% of the yield. That itself is very high for bio-waste material. If you get 25 to 35% of yield, that's it. You cannot get more than that. But 25% is very good, because your precursor is zero cost material. So even 25% yield is really good.
Hello. Hello.
Yes.
You're audible.
Thank you, sir.
Thank you, sir.
Next session is oral presentation. I request Srimati Lata CS Madam to give an introduction about session chair Dr. Ambrish, Professor, Department of Applied Electronics, Gulbarga.
Thank you, sir. Thank you for the very informative session.
Thank you, sir.
Good afternoon, one and all present here. A warm welcome to session 4 of the Today Online International Conference on recent Department of Physics. Prestigious Gales this session, Chair Dr. Ambrish, Professor, Department of Applied Electronics, to take over this session. Sir, please.
Good afternoon, madam. Thank you. I am in the line.
First presenter, K. Manjunath. First presenter, K. Manjunath.
Yes, yes. Yes, ma'am. Can I share the screen?
Yes, audible?
Yeah.
Am I audible?
Yeah, yeah. Just a minute, ma'am. I'm sharing my screen. Yeah.
Presentation.
Okay, thank you. Can I start, ma'am?
Yes.
Okay. Good afternoon, everyone. Myself, Dr. K. Manjunath. I'm a postdoctoral researcher in National Dangwa University, Taiwan. Here I am going to present study of magnetic memory and magnetocaloric effects in magnesium doped cobalt chromate nanoparticles. Outline of my presentation, introduction, method of synthesis, characterization, and results and discussions. Introduction. Generally, the cobalt chromate nanoparticles belongs to type 2 multiferroic materials. Multiferroics means which exhibit more than one of the primary properties such as ferromagnetism, ferroelectricity, and ferroelasticity. Because of this ferroic orders, the multiferroic materials are attracted because this metal can be used in various devices. Further, the cobalt chromate nanoparticle has spinel cubic structure having general formula Ab2O4, where A is the tetrahedral site, B is the octahedral site. Tetrahedral sites are occupied by the cobalt ions, and octahedral sites are occupied by the chromium ions. Because these spinal structures are also very attractive, because these spinal structures of samples showing very interesting properties such as ferrimagnetism, ferroelectricity, and multiferroic nature, as well as exchange bias effect, etc. So in the present work, we have systematically synthesized the magnesium doped cobalt chromate nanoparticle to understand the magnetic memory and magnetocaloric effect of sample. So in the present work, we used co-precipitation method to synthesize the sample. This is a schematic representation of co-precipitation method used in the present work. Characterizations. These are the characterizations which we use for present work. The XRD, which can be used to confirm the formation of single phase. Along, we can also identify the structure of the samples. Raman spectra to study the Raman vibration modes of sample. In the present work, we have studied the magnetic properties, magnetocaloric effect, and magnetic memory effect of the sample by using sphygmatometer. Results and discussion. These are all XRD patterns are refined by using foolproof software. The refined XRD patterns are indexed by HKL values. The index HKL values confirm the formation of single phase spinal cubic structure. From XRD patterns, we also estimated some structural parameters as is shown in table 1. Further, figure F shows the Raman spectra of magnesium doped cobalt chromate nanoparticle. According to group theory, the spinal structure of any samples can show only 5 vibration modes. In our samples, also clearly observe only 5 aberration modes, such as F2G3, F2G2, and F2G1. Along with we observed easy and AZ vibration modes. Further, it confirms the formation of spinal cubic structure. So come to the magnetic analysis, we can see that from figure A to E, This figure A to E indicates the temperature dependent of ZFC and FC meditation. All the figures clearly shows that two transitions, that is paramagnetic to ferromagnetic transitions around Curie temperature Tc, and one more transition we observed spiral transition temperature, spiral spin order at spiral transition temperature. Further also we observed blocking temperature, which can indicate the spin glass structure in our sample. To further confirmation of ferromagnetic nature in our sample, we have also done the temperature dependent inverse susceptibility measurements, and we have fitted by using Curie visa fitting. This Curie visa fitting is clearly confirmed that it is well fitted near Curie temperature. So this is a magnetic memory effect analysis. Here magnetic memory effect was studied using time and temperature dependent magnetation below Curie temperature, and also first time we also analyzed this memory effect by using isothermal remnant magnetation. Figure A and B clearly shows that when the system or sample is decreased from cooling from higher temperature like 50 Kelvin to 10 Kelvin, we have also stopped the cooling process at certain temperature, that is 45 Kelvin, 15 Kelvin, and 13 Kelvin. And when the warming, again we warm when the heating the sample from 10 Kelvin to 15 Kelvin, we can observe step-like nature. So that can also confirm the memory effect. Further to confirmation of memory effect, we also study the time dependent
Sir, please
magnetation.
conclude your presentation by another 1 minute.
Okay. Time dependent magnetation, it clearly shows that continuation of T1, T3. Initially T1, we relax the time for 1 hour at 45 Kelvin and 1000 ISTAT. When after 1 hour, just we remove the field and change the temperature for 1 hour. When the system is recovered to the normal position, that is called T3. So we can see the continuation of T1 to T3. It is showing that the sample history cannot change by field or magnetic field or temperature. So our sample shows good memory effect. Further, we also showed the magnetocaloric effect by using field dependent magnetation across Curie temperature. For to estimation of refrigerant capacity, we also showed change in magnetic entropy and RCP values. Our sample showing good RCP and delta SM values. So our sample is great material for using magnetic refrigeration application. So conclusion, XRD and Raman spectra confirm the formation of spiral cubic structure. Temperature dependent magnetation clearly shows the two transitions such as ferromagnetic and spiral spin order transitions. Further, the magnetic memory effect was studied below blocking temperature by using time and temperature dependent as well as isothermal remnant magnetation. And further, the magnetocaloric effect was used by below across the Curie temperature. It confirms that.
Thank you, Manjunath sir.
Okay, thank you. Bye.
Any questions from Amrish sir, please?
Hello. Am I audible,
sir?
madam? Hello, am I audible, madam? Hello.
Yes, sir. You are audible.
Yeah, Dr. K. Manjunath.
Yes, sir.
The results which you have presented are really very good, and the work carried out by is really excellent. What is the doping material that you have used in this study?
Sir, for the present study, we used magnesium, sir.
Okay. Have you tried with any other material?
Sir, we have also studied by using manganese, iron, nickel, sir. Yes.
Yeah. Which one is giving the best results out of all the materials which you have used?
Sir, some certain materials like I use iron doped to cobalt chromate. It is showing room temperature magnetic memory effect. Room temperature memory effect as well as room temperature magnetocaloric effect we observed. So that is only we are expecting as the best material for both applications.
Right. Yeah. Okay. Thank you.
Thank you, sir.
Yes. Next presentation will be Krishma Anand on the title
Yes, ma'am.
Z-scan measurements of TMDS polymer nanocomposites.
Good afternoon, everyone. Am I audible?
Yeah, you can start your presentation.
Yes, madam, you are audible. Please share your screen, madam.
Okay. Is my slides visible?
Yes, madam.
Okay. So good afternoon, everyone. I am Karishma, research scholar under the supervision of Professor S.K. Tripathi, Department of Physics, Punjab University, Chandigarh. My topic is Z-scan measurements of TMDs, polymer nanocomposites. So this is the outline of my presentation. First introduction, then synthesis, then characterization like structural properties, linear optical properties, and non-linear optical properties, conclusion and references. So various researchers investigated two-dimensional materials such as amexine, graphene, transition metal dichalcogenides, and black phosphorus due to their unique photonic and electrical properties. Among these materials, molybdenum disulfide has considerable attention due to its capacity to continually modify the electrical, structural, and optical performance. We have used polyvinyl alcohol as a host matrix due to its unique optical, mechanical, and electrical properties. PVA is used as a binder here due to its marvelous characteristic of flexibility, adhesion, and film formation. So this is the synthesis method. We have used hydrothermal method to synthesize MOS2 nanoparticles. The precursors used are sodium molybdate dihydrate and thiourea in the molar ratio 1:12. So we have firstly dissolved these precursors in 60 ml DI water and then the 30 minutes of magnetic stirring at 60 degrees Celsius. Transfer this solution to 100 ml stainless steel autoclave and place the autoclave in muffle furnace at 210 degrees Celsius for 12 hours. And then filter and wash and dry in oven at 60 degrees Celsius for 8 hours. Next is synthesis of polymer nanocomposites. So I have taken the 0.58% concentration of polymer PVA in 5 ml DI water and 3 hours of magnetic stirring was done at room temperature. Then I have prepared 3 different concentrations, 0.18%, 0.58% and 1% of MOS2 nanoparticles with 6 hours of magnetic stirring and 16 hours of sonication. So I have used drop casting method for thin film deposition. So these are the results. This is the XRD spectrum of all the 3 concentrations, 0.18%, 0.58% and 1%. We have seen that the peak height increases with increasing concentration, means crystallinity increases, and this may be due to the rise in density of MOS2 nanoparticles within the polymer matrix. Next, linear optical properties have been studied using UV visible spectroscopy and photoluminescence spectroscopy. Band gap is also calculated by extrapolating the tangent up to the energy axis of the top plot. In PL spectroscopy, the excitation wavelength is taken as 450 nanometer. This is the UV visible spectrum of the synthesized nanocomposites. We have seen that as the concentration increases, the absorption increases due to increase in the density of nanoparticles. And these are a talk plot for all the 3 concentrations. The talk equation is given here. In talk equation, n will take different values. N is half for direct allowed, n is 3/2 for direct forbidden, and 2 for indirect allowed, and 3 for indirect forbidden transition. In our case, the value of n is 1/2. The observed band gap values for the 3 concentrations are decreasing with increase in concentration, which indicates an increase in crystallinity and which is also confirmed by the XRD spectrum. Next is a PL spectrum of the synthesized nanocomposites. We can see from the figure that intensity decreases with increase in concentration because of introduction of new energy levels. As a result, recombination rate of electron holes reduces, lowering the PL intensity. Further, we can conclude that fluorescence quenching has occurred, which is due to the increase in number of non-radiative defects. So to calculate the non-linear optical parameters, we have used Z-scan method here. With continuous wave helium neon laser. Thus, Z-scan method is operated in 2 modes, open aperture mode and closed aperture mode. Open aperture mode is used to calculate non-linear absorption coefficient, and closed aperture is used to calculate non-linear refractive index. So these are the open aperture Z-scan curve for the synthesized nanocomposites. We have seen
Madam,
that.
kindly conclude by 1 minute.
Okay, ma'am. We have get the saturable absorption here, and this is the formula to calculate the non-linear absorption coefficient. These are the closed aperture curve to calculate the non-linear refractive index. So we have seen that for 0.1 there is self-focusing, and with increase in concentration it changes to self-defocusing. This is the formula to calculate the refractive index. We can also calculate the non-linear susceptibility using these parameters. So these are the results for the 3 samples. Out of all the 3 samples, I have got the best results for 1% concentration, and the order for susceptibility is 10⁻⁻⁴ centimeter square per volt square. So as seen from the results, the nanocomposites exhibit saturable absorption, and self-focusing changes to self-defocusing with increase in concentration. The best results for the best results obtained for 1 weight percent concentration. Due to these satiating linear and non-linear optical properties, these
Madam, you're running
nanocomposites
out
have
of
wide
time.
application. These are the references, and thank you.
Thank you, madam. Next presentation will be from Swati Sharma.
Good afternoon, ma'am.
Please proceed, madam.
Good afternoon,
The
ma'am.
title of the paper is The Study of Optical Properties and Conjugation of Quartzite in on Ternary Nanoparticles.
Good
Please proceed,
afternoon,
madam.
ma'am. I'm audible.
Yeah, yes, you're audible. You can present.
Madam, please share your screen. Yes, yes. Madam, you're not audible.
Madam, you're not audible, madam.
Swati, madam, you're not audible, madam.
Hello.
Yeah, now it's audible, madam. You can continue.
Good afternoon, everyone. Myself, Swati Sharma, research scholar from Department of Physics, Punjab University, Chandigarh. And today my topic of presentation is the study of
Madam,
optical...
your screen is not visible, but you're audible. Screen is not visible. Kindly check it, madam, please. Sorry, madam. The problem is with your side. Next presentation will be of Vidisha on unveiling contemporary advances, exploring trends in advanced materials within animation.
Excuse me, ma'am. Ma'am, आप भी share हो रहे हैं?
Your screen is not audible, madam. Swati, madam.
Ma'am, now it is presentable or not?
No, madam. You're audible, but screen is not visible. So we are moving towards next person. Vidisha? No. Next presentation. Nasreen Ansari. Nasreen Ansari, please proceed with your presentation.
Yes, ma'am. Hello.
Yes, madam. You can proceed,
Yes,
madam.
ma'am. Yes, ma'am.
Share your presentation.
Hello.
अरे वो अब next
Narsin Ansari, madam.
Yes, ma'am.
Please share your screen, madam.
I'll try, ma'am. Ma'am, other screen will share, so.
Continue, madam.
Good afternoon, ma'am. Hello.
You can share my. I also shared with you. इधर से share होने में कुछ problem हो रही है.
Ma'am, you can start with your presentation.
Sir, should I start?
Yes, please.
My slides are visible now.
Yes, madam.
Yes, madam.
Visible,
Yes.
visible, madam. You can proceed.
Okay, thank you. Good afternoon, everyone. Myself Swati Sharma, research scholar from Punjab University, and today my topic of presentation is the study of optical properties and conjugation of quercetin on ternary nanoparticle. This is the outline of my presentation, and today we are discussing about the nanoparticles are basically any material having dimension in the range of 1 to 100 nanomaterial. And today researchers are basically view about the nanoparticles because they have unique physiochemical properties like large surface to volume ratio and quantum confinement. Ternary quantum dots grab more attention in recent years as they are less toxic, environment friendly, and possess excellent optical properties. And in today's presentation, we are discussing about copper indium sulfide ternary quantum dots for a drug conjugation. And quercetin is employed as a anti-cancer drug because they have a less adverse effect. And the change in the optical properties of copper indium sulfide nanoparticles is studied after the drug is conjugated on them. Now the synthesis method, we are using the 500 microliter of drug to conjugate on the
स्वाति शर्मा जी, आपका स्क्रीन नहीं आ रहा है. Your screen is not visible now.
मोबाइल है, थोड़ा इधर आ जाए.
There is no option to share the screen.
Screen not coming. Screen.
I think the other participant has shared the screen. I think one should exit from the screen now.
Okay, sir. I'm exit.
Thank you, madam. Next presentation will be of Prabhakaran Ningaya Patil. Prabhakar sir, please proceed with your presentation. All the participants are requested to check your connection, please. The screen is visible. You can proceed, sir.
Hello, madam.
Yes, sir. You can proceed, sir.
Yeah, madam.
Yeah.
Good afternoon, everyone. Myself, Prabhakaran Ningaya Patil, research scholar, Department of Physics, Kulbur Institute, Kalaburgi, working under the supervision of Professor V.M. Jali. So today, I am presenting the paper on green synthesis of copper ferrite nanoparticles by honey-mediated sol-gel autocombustion method. So my presentation outlines are introduction, synthesis and characterization, result and discussion, summary and conclusion. So as we all know, the ferrite nanomaterials plays an important role in advanced technological applications like sensors, magnetic recording media, energy storage devices like that. So today, in this work, we have chosen copper ferrite for this study because they are preferable soft ferrite and because of their features like phase transition, electrical switching, semiconductivity, and magnetic properties, and their chemical stability. So the method of preparation has significant effect on crystal symmetry and cation distribution, size and shape of the ferrite nanoparticles. So in this present study, we have chosen copper ferrite nanoparticles using green synthesis method, using honey as a green fuel, and the effect of annealing temperature on the structural, morphological, and vibrational optical properties have been studied. Synthesis, for synthesis of these copper ferrite nanoparticles, we have chosen green sol gel autocompression method. First, we have chosen the stoichiometric amount of metal nitrates and the honey, and you dissolved in the appropriate amount of deionized water, and further it kept for stirring, and subsequently the pH of the solution was balanced to 7, stirring at the 880 degrees Celsius. Further, it is continued for stirring and heating at 100 degrees Celsius to attain the autocombustion reaction. Once it undergoes the autocombustion reaction by exothermic reaction, it yields the flaky mass out of that. The obtained flaky mass is ground using Agaton motor. Further, it is annealed at 400 degrees Celsius for 2 hours to get the copper ferrite nanoparticles. So further, it has been taken for further characterization, XRD, SEM, FTIR, and UV DRS spectroscopy for analysis. XRD result confirms the spinel cubic phase structure with FD3M space group with ICDD data file. As we can see, the as prepared sample is showing the pure phase with the spinel cubic phase, and the trace amount of impurity phase are present, that alpha Fe2O3 copper oxide were observed in both samples, and the crystallite size was calculated using Debye-Scherrer equation. It was found for as prepared sample, it is 17 nanometer, and it decreases to 12 nanometer after annealing at 400 degrees Celsius. So it is noticed that shift in the 2 theta towards the lower value for the as prepared for the annealed sample. It is because of the significant effect on the preparation condition, which led to the increase in the lattice parameter and decrease in the crystallite size with the increase in the annealing temperature. From some micrographs, we can see the agglomerated morphology with irregular and unorganized structure. Additionally, we can see the voids which are present in the sample, that because of the release of gas during the combustion process. From the FTIR analysis, we observed that the wave number around 607 and 607.28 is observed because of the presence of metal ion stretching vibrational mode. Along with that, for as prepared sample, we have observed the vibrational band around 1083 and 1120.
Prabhakar sir, please conclude it by another 1 minute.
Yes, madam. Yes. So for the annealed sample, these nitrogen bending and carbon oxygen bending vibrational bands are disappeared because of the annealing condition that confirms the removal of nitrate, residual nitrate present in the sample. From UV-DRS spectra, we can reflectance mode we have carried out by using this Kubel-Kumang function. We have fitted the curve, and we have got the direct band gap value around 1.61 and 1.65 for as prepared and 400 annealed sample. There is increase in the band gap value. It is due to the attribute due to the quantum size effect of nanomaterials. We can summarize and conclude that the copper ferrite nanoparticles can be synthesized by using honey-mediated sol gel autocombustion method, and the prepared sample is exhibiting the cubic spinel phase along with the trace amount of oxide phases like copper oxide and alpha Fe2O3.
Time up, sir. Thank you.
Yes, ma'am.
Next presentation will be of P. Aruna. P. Aruna, Jane Christie. Next presentation.
Next presentation will be Zheng Li. Next will be Ashok Yadav.
Yes, it's my turn.
Yes, ma'am.
Zheng Li. You
Ashok
can carry
Yadav.
on, sir.
Yes, but I cannot demonstrate my presentation.
Hello, ma'am.
Can you see the presentation?
Yes,
Yes, sir, you can continue.
Today I'm going to talk about the dielectric properties of these materials, which first we talk about history. We process this material using top-down method, and this contains high pressure and shear deformation. And this method was awarded as the Nobel Prize and Lenin Prize in the past. And for this method, it contains mechanical dispersion, and it's like the mechanical force will transfer into surface activation, or it totally destroy the structures, and it's like a mechanical activation. And the generate of the defects, and defects contains of the pound defects, line defects, and dislocation. And different kind of defects would make the materials into different malleable state. And accumulation of defect, and sometimes the defect would be saturated, and sometimes it would have the recrystallization process. And for the mechanical activation, the equipment, some of it is the kind of ball mining method, which is popular, but they don't have pressure. And using Bridgman iris, they can achieve high pressure, but nowadays using diamond MA cells, which can achieve maybe 60 gigapascal. And on the left, the microscope is the sample before mechanical activation and after mechanical activation. After mechanical activation is like the fine particles was on the surface of the big particles. And on this table, we can see that after the high pressure torsion, some of it, the transition was changed, and some of it was not changed, no significant change. And for our materials, and we see the dielectric permittivity of this material. Before mechanical activation, we cannot observe the Maxwell-Minkowski realization at this temperature. But after mechanical activation, we see that it was changed. And for the second materials, and we see it affect not only the Maxwell-Minkowski realization, also affect the magnetic phase transition temperatures. And when the pressure was increased, this phase transition, magnetic phase transition, was vanished. And for the next materials, it's much more complex because of this material contains two different symmetries, hexagonal and orthorhombic. And when it interacts with the pressure and shear deformation, it would have the structure change and the physical property change. And for hexagonal and orthorhombic, they have different phase transition temperatures, have different magnetic and ferroelectric phase transition temperatures. And for the materials which before and after mechanical activation, we can see the charge carriers change. So the conductivity changed a lot, and we can see C and G, they were the same materials, and one is before and another is after this kind of process. And here's the conclusion. And thank you very much.
Thank you, sir. Next presentation will be of Ashok Yadav.
Yes, ma'am.
You can proceed, sir.
Hello, ma'am.
You're audible, sir. Share your screen, please. Ashok, sir. Please share your screen.
Ashok Yadav, Department of Physics School of Basic
Screen is
Applied
not
Science
visible.
Career Point. जी मैम. Screen.
Please check
Not
your
coming
connection.
screen.
Ashok Yadav.
Ashok Yadav, sir, not coming to the screen.
Ashok Yadav, sir. If you have any issues, we'll proceed with next one. Yes. Next presentation will be of S. Pramodini. Yes, Pramodini, madam. Yes. Next presentation will be of SP Godse.
Yes, madam.
Sir, you can proceed, sir. Share your screen, sir. You are audible.
Okay, madam.
Yes.
Good afternoon, everyone. Today's international seminar. Audible, madam? Hello, madam.
Yes, you can proceed. You are audible.
Okay, madam. Good afternoon, everybody. International seminar. My topic: structural properties of magnetic spinel cobalt ferrite synthesized by oxide precursor method. I am research student under the guidance of Lohar sir. Outline in my topic: introduction, experimental, result, and discussion. Introduction is nano spinel ferrite R. Ferrite is a class of ceramic compound and iron containing metal oxide. Its uses, application, and ferrites: inductors, high density right once optical recording, electromagnetic interference suppression, bioscience catalyst in this very useful application in ferrites, and synthesis of sample, physical synthesis and chemical synthesis. My method is oxalate precursor method, other is ceramic method, wet chemical method, and co-precipitation method, sol gel method, etc. Synthesis of spinel cobalt ferrite by oxalate precursor. Oxalate precursor method is very costless, and in this method, sample of ferrites is a very better homogeneity and high purity, lower processing temperature, better size and morphological control, more uniform phase distribution in multi-component systems like ferrites. Characterization technique is used: thermal analysis, TJ, DTA samples, structural analysis, X-ray diffractometer, scanning electron microscope, and transmission electron microscopy, infrared spectrometer, result and discussion in this topic: thermal and IR. thermogravimetric analysis, it's clear that graph after 400-degree temperature, the graph reading is constant, then sample is well prepared. IR and next structural analysis of precursor XRD. XRD pattern of calcinated by cobalt ferrite. In this graph, observe XRD diffraction peaks where assigned is 220311, 221, 400, 422, 331, and 400 planes confirm formation of cubic spinel structure. Without any secondary phase, the average crystalline size from the most intense 311 were calculated using XRD data, which found is a scalar formula 26.599 nanometer. The calculated value of lattice parameters cobalt ferrite is A is equal to 8.365 angstrom. Structural analysis of precursor XRD and IR. IR spectrum calcinated. Two major IR absorption bands observed in this study. The band V1 and at 585 centimeter inverse is allocated the tetrahedral A site. Even the decreased wave range Phi2 at 436 centimeter inverse is allocated to octahedral B site. And next, same and same images in this slide. Same micro of calcinated and same micrograph of calcinated cobalt ferrite. Same and same micrograph calcinated in a cobalt ferrite oxide nanoparticle synthesized by the oxalate precursor technique show uniform structure with the particle size distribution elongated spherical. Cobalt ferrite particle were also seen the same and same images. Hysteresis loop of calcinated PSM vibrating sample magnetometer. In this analysis, room temperature loop recorded by use of vibrating sample magnetometer. Saturation magnetization is first of 15.72 mu per gram. Remescent magnetization.
Please last 1 minute.
Okay, madam. Last value of cobalt ferrite nanoparticles is 58.70 mu. Next conclusion. Nanospinel cobalt ferrite synthesized by oxalate precursor method. Synthesis of oxalate precursor characterized by room temperature is the range 400 to 4000 centimeter inverse. Oxalate precursor calcinated 600 to obtain desired cobalt ferrite. XRD pattern of calcinate cobalt ferrite confirm formation of cubic spinel structure without any secondary phase. The major IR absorption bond is 585 centimeter and 436 centimeter. Were allocated the tetrahedral A site and the octahedral B site respectively. Very fine spherical cobalt ferrite particles. Some quantity of aggregation may be observed with the same and same images. The saturation magnetization observed room temperature is 58.72 EMU per gram. Thank you. Okay, madam.
Next presentation will be of Rupa Margaret. Sagar Godse sir, you can proceed. Rupa Margaret. Next is S. Akshay.
Hello.
Akshay sir, you can proceed, sir. Please share your screen, sir.
Ma'am, am I audible?
Yes, sir. You are audible. Share your screen, sir.
Ma'am, I'm getting the message as host has disabled attendee screen sharing.
Sir, it is enabled.
No, ma'am, I'm getting the same message. Host disabled attendee screen sharing.
Sir, it is enabled. Please share your screen, sir.
Oh, who is Akshay?
Akshay.
No, ma'am, I'm getting the same message.
Yes, sir.
Sir, you can proceed now.
Yeah, now I.
Akshay दिग्गजन आहेत.
Visible, ma'am. I have shared.
Yes, sir. Yes, sir. You can continue.
Okay. Yeah, good afternoon to one and all present here. Myself, Akshayas, research scholar at Department of Physics, East West Institute of Technology, Bangalore. My title of talk is Photoluminescence Studies of Copper-Doped Zirconium Titanate Nanoparticles. The outline of the talk is Introduction, Materials and Methodology, Characterization, Results and Discussion, Conclusion, and some of the references. To start with introduction, nanocomposite materials are the one that combine one or more separate components in order to obtain the best properties of each component. Zirconium titanate is the intermediate compound of zirconium oxide and titanium oxide system. And the zirconium titanate based materials are quite interesting for variety of applications due to their attractive properties like high resistivity, high dielectric constant, and excellent temperature stability. Photoluminescence is the process by which light energy is absorbed by the material and a fraction of it is emitted in the visible or near visible region. We can divide photoluminescence into two categories depending on the nature of excited state as fluorescence and phosphorescence. And also luminescence materials have found a wide variety of applications in information and display technology. Starting with materials and method, we have adopted solution combustion method to synthesize the zirconium titanate sample. First, we have taken titanium tetrabitoxide, which has been converted into titanyl nitrate, and stoichiometry amount of zirconyl nitrate along with copper nitrate as a dopant has been added. These three mixture has kept for a magnetic stirring. Before that, the aloe vera extract has been used as a reducing agent. All these four mixture has been kept for a magnetic stirring, and which is followed by combustion at 500 degrees centigrade, and the same was calcinated at 720 degrees centigrade for 2 hours. Finally, we have obtained a zirconium titanate sample which has been copper doped. And next, the synthesized sample was subjected to different characterization techniques like PXRD, SEM, EDAX, TEM, UV visible, FTIR, and photoluminescence studies. Here, this is the figure which depicts PXRD of zirconium titanate, copper doped zirconium titanate prepared by solution combustion method using aloe vera as a reducing agent. And here the sample shows the formation of zirconium titanate, which is matched with 0103404115 JCPDS file with space group PBCN 60 and orthorhombic structure. We have not observed any other impurity peaks here. The pure orthorhombic structure has been obtained, and these are the crystallite size calculated using Sherras method and WH plot, and also the crystallinity for different mole percentage has been tabulated here. And next, moving on to scanning electron microscopy. SEM is used to obtain the information about the surface topography, and here the figure shows the surface morphological analysis of copper doped ZTO at different magnification. And we can observe here the morphology consists of large number of irregular shapes and size flakes of nanoparticles along with the agglomeration. As the copper dopant concentration increases from 1 to 9 mole percentage, agglomeration as well as the size of the flakes increases. And when we look at the EDAX pattern, it clearly indicates the presence of zirconium, titanium, oxygen, and copper atom, and absence of other impurities. Next, moving on to FTIR spectroscopy. In order to create a chemical fingerprint, FTIR analyzes light distribution in the library. the vibrating molecules in the IR region of the electromagnetic spectrum. And here the FTR spectra was recorded from 400 to 4000 per centimeter for ZTO. And the functional groups present in the synthesized nanoparticles are sensitive to IR region. And the wave numbers of different identified functional groups and their marks are tabulated here. And next, moving on to UV visible spectroscopy, where we have calculated the band gap, and also the figure shows the absorption spectra of copper doped zirconium titanate, which has a high intense absorption peak at 325 nanometer, and no other less intense peaks are observed. And also the wooden talk plot has been used where the direct band gap is obtained, and it was found to be 2.9 to 2.55 electron volt. And here we can observe energy gap decreases as dopant increases. This band gap narrowing is mainly due to the introduction of new energy levels within the band gap of ZTO by copper ions. Next, coming to photoluminescence studies, we have recorded this PL emission spectra by keeping excitation spectra as 471 nanometer. And this emission peak centered at 706 nanometer might be due to oxygen defects. Yes, ma'am. Oxygen defects created due to the doping of copper ions into the host matrix, and also the PL intensity increases with increase in dopant concentration up to 5 more percentage, and thereafter it decreases. This decrease in PL intensity is due to concentration quenching. Next, coming to CCT diagram, the CIE coordinates were calculated from the PL spectra, and in the current investigation, we have found average CCT to be found to be 3564 Kelvin. Therefore, this clearly.
Sorry, sir, it's getting late. Next person is Nagraj MK. Nagraj MK, sir.
Hello.
Yes. This is
Myself,
Nagraj MK.
Vivek.
Is Nagraj MK. Next is Shakil Nawaz.
Hello.
Shakil Nawaz.
Yes, ma'am.
You can start. Please share your screen, madam.
Ma'am, can you make me as a host? Yeah.
Sir, you can proceed, sir.
Yeah, ma'am.
Share your screen, sir.
Yeah, sir.
Hello.
Yeah, is it it hello? My screen available?
अच्छा sir.
It is visible. Please proceed with your proceedings. Sorry, presentation.
Yes, sir. Yes, sir. Good afternoon, everyone. Let me introduce myself. I am Shakil Nawaz, working as a research scholar in Presidency University under the supervision of Professor Dilip Ramakrishna. So, before I start my presentation, I would like to thank the Kelly Society and the PC Javin Science College for organizing this international conference and giving me an opportunity to present my research work. Today, I am presenting my research work titled as Palladium and Cobalt complexation via curcumin as a ligand, a novel material for nonlinear optics. The agenda of presentation as follows here. As follows. To begin with the introduction, so coming with the definition of nonlinear optics, the interaction of applied electromagnetic field in various materials to generate a new electromagnetic field which altered in their frequency, phases, and other physical properties. In last few decades, there is a development of nonlinear optical field, which development of lasers, which is having a high brightness and high coherence in nature. So for the application of like like optical communication, optical data storage, optical switching, and other optical devices like optoelectronic technologies. So coming to the material which should possess a character called charge transfer polarization character and the non-centrosymmetry lattices should be there in the material. Later, in few decades, there is a use of organic molecules and organic polymers for these kind of applications. Now the metal organic framework has been enhanced so that it will overcome the drawbacks of those organic and organic polymers, like easily accessible of electrons and large pi electrons delocalization. So as this is a schematic representation of nonlinear optics where laser as well as the material and the detector will be there. So I'm using two techniques here in my research. So Z-scan technique, where this technique is mainly of identifying the nonlinear refract index of the material as well as measuring the intensity dependent nonlinear optical susceptibility of third order nonlinear optics. And another technique is optical corrugate, where we are using to identify the change in refractive index with the proportional of electric field, as well as which we used as optical switchers. So I am using curcumin here. Curcumin is basically of two types, keto form and enol form. So according to the literature, curcumin is basically used in the medicinal applications, but nonlinear optics where I'm trying to incorporate this curcumin with the metal to perform this nonlinear optics because of the high conjugation in curcumin. So here the metal complexes of curcumin, before it was a symmetric in nature, after complexation with the metal, so it forms non-centrosymmetry, which is suitable for nonlinear optics. Till now, no reports has been identified with curcumin metal complexes for nonlinear optics. So I am working on it. The experimental procedures, I have synthesis two complex, a cobalt and a palladium triphenyl phosphine with curcumin. So the procedure was simple, as we have to take two equimolar solutions of ligand as well as metal precursor in methanol, stir it and reflect for 3 hours, and in a basic condition of triethylamine I am adding. Later the product will be filtered and washed and dried it. The scheme as represented here of two complexes. And the physicochemical data, as mentioned, as theoretical
Last data well minute, matches sir. with the yeah ma'am. And here these are the characterization of these FTR ESR, whatever the synthesis complex has been well matches with the theoretical as well. Later the application part of the synthesis complex is using Z-scan method, where I got the cobalt as 10 power minus 23 in the range of 10 power minus 23 centimeter per gigawatt, and palladium I am getting 10 power minus 18 centimeter per gigawatt. The second technique I have used is optical corrugate, where I'm getting is around 3.2 into 10 power minus 10 ESO and 2.8 into 10 power minus 2 ESO. Then the transition absorption also we have done, where and the transition kinetics, it shows that the transition measurement of the cobalt and the palladium, where affinity of the electrons is more in the cobalt and compared to palladium. To conclude my work, I have synthesized two complexes and characterized by all the spectrochemical studies. Along with that, we have used two methods to done the nonlinear optical susceptibility using optical corrugate and Z-scan techniques, and we have used the open aperture Z-scan method with a laser intensity of 800 nanometer, and the normal and this one, the optical limiting will be around 100% to 78 and 100% to 69, as well as it was used for optical switches and optical modulators. Further, it can be used in space technology as fabricated as films and glasses. So finally, I would like to thank all the international conference for recent trends in advanced materials and college, PC Jabin Science College, as well as faculty and teaching faculty. Hello. Thank you, sir.
Yeah,
Next
ma'am.
will be Yoyer's hand. Mr. Zhang? Mr. Zhang? Next, Ashok Yadav. Ashok Yadav. Ashok Yadav. K. Gayatri.
Hello.
Gayatri, madam. Nisha Mahepal. Nisha Mahepal. Madam, you can start. Share your PPT, ma'am.
Ma'am, you are not audible. Mr. Mahipal, please share your screen.
After Nisha Madam presentation, next presentation will be of girl theme, Rosa. Please be ready with your PPT. Madam, you please share your screen. Nisha Madam. GB Rosa. Last call. GB Rosa. GB Rosa. Next will be Sandeep. Yes. Sandeep, yes. Sandeep, yes.
So, 1 minute, ma'am.
You can proceed, sir.
Am I audible, ma'am?
Yes, you are audible, sir. Please share your screen.
Okay, 1 minute. Hello.
Sir, you can continue, sir.
Yes, ma'am. Are you able to see my screen?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir. You can continue, sir.
Good evening, one and all. I, Dr. H.G. Sontakke, Assistant Professor in Chemistry from Lonavala Arts, Commerce and Science College. My topic of presentation is chemistry and pharmacological applications of benzimidazole and its derivatives. The outline of my talk is it includes abstract introduction, methods, and biological significance of some of the benzimidazole and its derivatives, including conclusion, acknowledgement, and references. So, start with abstract. As a chemistry fellow, we all are aware about of benzimidazole. and it's as we know that it is heterocyclic aromatic organic compound, and it shows the potent biological activity. Its therapeutic potential was identified since 1944, and it hold a very important role in the world of heterocyclic system, and due to its presence in diverse array of bioactive compound. It includes anti-ulcer, anti-hypertensive activity, analgesic activity, anti-inflammatory, antiviral, antifungal, anti-cancer, and many other activities. Keywords: benzimidazole, therapeutic potential, biological significance, heterocyclic compound. These are the some keywords which is used in the abstract. Introduction. So this is the structure of benzimidazole. It is bicyclic ring. One is benzene ring, which is fused with 5-membered imidazole ring. It contains 2 nitrogen atoms. Benzimidazole is heterocyclic organic compound that consists of benzene ring, which is with imidazole ring. This is the unique chemical structure. Benzimidazole is a bicyclic structure. 6-membered benzene ring fused with imidazole ring, as I told you just. The molecular formula of benzimidazole is C7S6N2. It has a melting point 170 to 172 degrees Celsius. It is sparingly soluble in water, more soluble in organic solvents such as ethanol, chloroform, as well as DMF. Benzimidazole is not commonly found in nature, but you can synthesize easily in the laboratory, and it has various application in the pharmaceutical industry, not only in pharmaceutical industry but also in agricultural field. Method: we have prepared this biological, we have put here some biological potent benzimidazole and its derivative by doing the literature survey. Basically, we have used the Google Scholar for downloading the many reviews and research articles. These are some example which shows the biological significance of used benzimidazole. So this is the first example. This is structure 1.1, which shows diuretic activity, which was studied by the Srinivasan and colleagues. Also, the second example 1.2, it shows the anti-inflammatory activity. These are the 1.3. This structure shows the biological potency, particularly antifungal activity. It shows. Structure 1.4 shows the anti-allergic and anti-histaminic property. So structure 1.5 also shows the anti-inflammatory and anti-hypertensive activity. Such type of many structures we have put in our presentations. Going to the conclusion, the benzimidazole molecule has held a significant position within medicinal chemistry due to its biological activity and straightforward heterocyclic structure. It has emerged as a pivotal component in the pursuit of creating novel drugs with potential biological effects. Owing to the acknowledgement, I am thankful to my PhD research guide, Professor Dr. S.P. Vartale, for his invaluable guidance. These are some references I put over here. With this, I complete my presentation. Thank you very much for giving me the opportunity to make this presentation in the one-day online international conference. Thank you very much.
Thank you, sir.
Next
will be B.N. Shweta. Shweta, ma'am. Rosa, madam. B.N. Shweta. Shweta. GB Rosa, madam. You can start, madam.
Theory and passivity. Rest number ABR.
So next presentation will be of Shijo Thomas. Shijo Thomas, you're there?
Next, Zhang Huili.
Yes, I'm here.
You can continue, sir.
Thank you. Next, I'm talking about the impedance and the magnetodielectric magnetoresistivity property of one of the materials. And for this material was synthesized by the solid phase reaction method. And after this, we're using different equipment to check the properties and also measure the impedance spectroscopy. For different concentration of this material, it contains two different phases, hexagonal and ultrarhombic. And for the second picture, it contains two phases. So we can see from the microscope, it has the bigger particles and also have small particles. And here's the size distribution. And next we compare with before. Next compare with before high pressure torsion and after the high pressure torsion. We can see the actual diffraction peaks. Before high pressure torsion, it was very sharp. And after high pressure torsion, it's become much wider. That means the size is become smaller. And we calculate the size, we should use in the Williamson-Hall plot. Because of it contains the size change, also the concentration of the deformation. And we also measure the magnetic properties. We see that the coercivity for the concentration is much higher. And for the magnetic analysis, we're using the law approach to magnetic saturation. And we also calculate the measure fatigue compared with the reference papers, and also the band gap optical spectroscopy. And next is for the impedance. And impedance contains two parts. One is the real part, another imaginary part. And when sintering the ceramic on mechanically activated powders, and some of the dislocation are retained, some are healed. So after synthesize this kind of ceramic, it should have different kind of impedance spectroscopy. We see the impedance changed with the pressure of mechanical activation. And using this formula, we can calculate the activation energy. It has a significant change. And also, we can using the approximation to get the green capacitors and the green conductors. And the next is dielectrical magnetoresistance analysis. And this was measured in the magnetic field using different frequencies. And first we see the samples which was mechanical activated. It contains a large amount of defects and dislocation. And we can see that the magnetic dielectric and magnetic resistance, they were going in one direction, but they cannot come back to the original state. And we compare with the pure sample before mechanical activation. We see that they can come back to the original point, almost come back. And we also try to measure the mechanical activated samples. And after many rounds of the measurement, and it become
last minute, sir.
Okay, thank you. I repeat many cycles, and it's become looks like a mirror reflection to each other. And thank you very much. Do you have questions?
Thank you, sir. Next presentation will be of Rupa Margaret. Rupa Margaret.
Yes, ma'am.
Madam, you can proceed, madam.
Is my screen visible, ma'am?
No, ma'am.
Hello?
Not
Yeah,
visible.
Now?
It's not visible.
Just a minute. Now, ma'am?
Sorry, ma'am.
Is it visible now?
No.
I'm sharing it.
Ma'am, please share the screen, ma'am.
Ma'am, I'm sharing it.
Now you try.
Yeah. Now?
Yes, ma'am, it is sharing. It is sharing.
Okay, ma'am. Can I start now?
It's not visible.
No?
After Rupa Margaret Madam's presentation, next presentation will be of MY Sophie. Rupa Madam, please share your screen.
Ma'am, I'm sharing it. I think some connectivity issue.
It's okay, ma'am. Thank you. Next will be MY Sophie. Shaina. Sophie, you can continue, sir. MY Sophie. Is it audible? Sophie, sir, is it audible? We are able to see your screen, sir, but you are not audible. Mr. Mudasir Yoni Sophie. Audible? Mr. Sophie, it is audible?
Hello.
Hello.
Hello, ma'am. Yes, ma'am. Please unmute my mic. Hello.
Yes, please.
Hello. Am I visible?
Yeah, it's visible and audible. Please continue, sir.
Okay.
Okay.
Good evening, all. My name is Mudassir Ayon. Okay. I am from Islamia. The topic of my oral presentation is investigating the physical characteristics of double halide lead-free halide double perovskites.
How is the party?
So here are the outlines of the presentation. Introduction to the research problem, perovskites, and details of work done on the research, structural, thermodynamic, electronic, and transport response. So here is the introduction to the thermoelectrics and why we need thermoelectrics. Actually, the energy crisis bottlenecks the economic development of the nations, and we the major energy spot during the previous have been the fossil fuels, but now renewable energy production, energy storage, and energy transportation have gained very much research interest within the scientific community with every passing day. It is actually because we have been so dependent on fossil fuels that they have created a lot of environmental issues like global warming, degrading the quality of air, especially in metropolitan cities. Moreover, the devices which we use in everyday life in daily basis, they are limited and their efficiency is limited. So the heat coming out of them is lost to space. Most of the heat is that's lost to space. So waste heat is everywhere. Hence, what we need, there is a need to design some smart devices that can harvest this, at least some part of this waste heat into usable form and convert this productively, and we can use that waste heat to produce electricity. Now, what are perovskites? Perovskites came into light after the discovery of Ca2IO3 by Gustav Rose Perwasky. And they constitute two subclasses, oxides and halides. Oxides contain oxygen at anionic position, while halides contain halides like chlorine, fluorine, and bromine at anionic positions. Perovskites, they have been worthy to research because they contain so much physics-rich properties, like they have magnetoresistance, multiferricity, they contain half metallicity, they contain thermoelectric figure of merit nearing 1, and they also have superconductivity. Now, for ideal perovskite structure, we have some conditions to follow. We have some metrics to follow. If these metrics are fulfilled, we can say the given material may possess cubic stability. Double perovskite, they are actually when a unit cell is doubled along the x and y axis and are introduced two sub-octahedras, they constitute a double perovskite. And now here's the methodology. The methodology has been followed here. First principle calculations within Wien2K package, and the exchange correlation function, they have been treated as PB, GG, generalized gradient, and modified approximation on top of GG. The cutoff parameters have been set to control the basis set and computational time as 7 and Lmax 10 and K points 1000. Elastic. Here are the results and discussions of my problem. First of all, we ensured the structural stability of this material because it is necessary to know the structure of an unknown material. The structural stability, it has been defined with the help of some factors, matrix, including tolerance, octahedral, and new tolerance coefficient. And they all have been found to be within the range of cubic stability. Moreover, the calculation.
Last minute, sir.
Yes, ma'am.
Last minute.
Yes, I'm going directly for the application part. Here is the application part of this material, that's thermoelectric coefficients. For this, we have calculated Seebeck, electrical conductivity, thermal conductivity, and figure of merit. We can see Seebeck exhibits various peaks in the entire range of chemical potential and reaches 3000 microvolt per Kelvin, and electrical conductivity is some decent 1.4 sigma by tau, and thermal conductivity is also at 300 Kelvin. Thermal conductivity is too low, which facilitates the higher and which facilitates the good thermoelectric response of this material. Finally, we have computed the ZT, that is thermoelectric figure of merit of this material, which is around 0.9, which is around 0. That is nearly equaling one value at room temperature 300 Kelvin. This indicates that this material can be effectively used for thermoelectric device applications. Moreover, the carrier mobility of the charged carriers is very less. We have computed that effective mass and that is less than 0.5, which facilitates greater carrier mobility of the charge carriers, and hence approving this material for transport properties. Thank you.
Thank you, sir. Next, Shahnaz Nadaf.
Yes, ma'am.
Mr. Nadaf?
Hello. Yes, ma'am.
Okay, sorry. Ma'am, you just share the screen.
Okay, ma'am.
Shahnaz?
Yes, ma'am. I'm sharing, ma'am.
Yeah. Shahnaz? Shahnaz Nadaf?
Shainaz madam. Madam, you're there, no? Shainaz Nadaf madam.
Last call. Shahnaz?
Hello. Ma'am. Hello, ma'am.
Shahnaz? Are
Hello.
you there, Shahnaz?
Hello, ma'am.
Yes, please share the screen.
No, ma'am, it's not sharing, ma'am. Network problem is there, ma'am.
It is enabled. Please check. We'll come back to you, madam. Lakshmi madam. Lakshmi Hatia. Lakshmi Hatia, you can continue.
Hello.
Hello, Lakshmi madam.
Yes, ma'am.
You can continue, madam.
Yes. Yes. Ma'am. Is my screen is visible?
No.
Oh, okay.
Miss Lakshmi? Lakshmi? Is it audible? Miss Lakshmi? Shainaz? Shainaz? Next will be
Madam,
Vijay.
unmute the call for the presenter, madam.
Sorry, sir.
Unmute the presenter voice, madam.
करवानी हमें थी Zoom में थी मेरे PPT
Sorry. JB Rosa?
Come forward and start presenting. Rupa Madam, Akshay Yadav, and last call for Shainaz Nadaf.
Vijay Gupta?
जल्दी कर पता हमें कोर्स को
Yeah, ma'am.
Vijay Gupta, sir, you can start, sir.
But I think the problem is there. No, I am not having at the moment. No, the video recording. No, I mean, say I can tell the audio recording only now. Audio clipping I can give now. Is it possible to give now?
So PPT presentation is not there.
Yeah, I have given this. I have shared it to the mail of the institutions now. First, I have given the abstract first now. And after 1 or 2 days, I have shared this PPT to your institutions now. But that has been turned down by the institutions now, sir. And at the moment, I am having.
Sir, you can share the PPT with your mobile phone only. You can do it.
Okay, sir. Let me do now.
You can share the screen of your mobile and open the PPT and present it.
Okay, let me do now, sir. Yes, sir. It is looking now.
Hand over, Mary.
Thank you all for the participants. Now, vote of thanks by Dr. Jagdish Angdi, V, convener, one-day conference.
Good evening, everyone. Good evening, everyone. Respected speakers, principal, and all participants. I, Dr. Jagdish Angdi, Assistant Professor, Department of Physics, PC Job in Science College, Hubballi, India. Ladies and gentlemen, it's my pleasure to deliver the vote of thanks on the occasion of one-day online international conference on recent trends in advanced materials. We received an excellent response to the conference from all over the globe.
we have received nearly 200 abstracts for this conference, not only from India, but from various parts of the world, like China, Russia, Turkey, Saudi Arabia, Taiwan, Brazil, Romania, etc. Out of 200 abstracts, we have selected only few for oral presentation due to time constraints. Speaking of today's conference, we express our sincere thanks to Honorable Chairman of KLE Society, Dr. Prabhakar B. Koresar, for unceased support in organizing this conference. We are also thankful to the Board of Directors, Board of Management, life member of the KLE Society, and principal of our college for their constant encouragement and support. I thank all the invited speakers, National and International Advisory Committee, Organizing Committee, and reviewers for their cooperation, help, and support. And I also thank all the participants for your active participation and making this conference a huge success. Hope you all enjoyed it. Thank you one and all. Dear participant, we are sending the feedback link to in the WhatsApp group. All of you fill that WhatsApp that feedback form. You get the certificate. Yeah. Thank you one and all.